Hundreds of millions of rocks orbit the Sun within the asteroid belt between Mars and Jupiter, but only some of them come relatively close to Earth. NASA classifies asteroids orbiting within 30 million miles of our planet as near-Earth objects, and inside this group, there are particularly worrisome objects. Those are so large and orbit so closely to our home planet that they could turn into a real threat to the world should a direct collision occur. At the moment, NASA is keeping a close eye on an asteroid named Bennu. It's a fairly large space object that might smash into our planet in 159 years. According to the experts, the asteroid, which was first spotted in 1999, is quite likely to drift into the orbit of our planet. If it happens, it might collide with Earth by the 24th of September, 2182. Asteroid Bennu is thought to be taller than the Empire State Building. If that hits our planet, the collision will release 1,200 megatons of energy. That's an enormous amount of energy that nothing built on Earth could produce. Scientists from NASA believe that during the flyby in the 22nd century, there's a tiny chance that the asteroid will pass through a gravitational keyhole. That's a region of space that might set the space traveler on a certain path, which could result in the asteroid crashing into Earth. Bennu flies by our planet every 6 years. It has had 3 close encounters with Earth in 1999, 2005, and 2011. These days, scientists estimate the chance of the asteroid hitting our planet by 2182 as 1 in 2,700. That's more than 5 times a person's chance of being struck by lightning. But even though Bennu's chance of colliding with Earth are quite low at the moment, the space rock has still been categorized as a, quote, potentially hazardous asteroid, all because it might come as close as 4.65 million miles from Earth. That's the reason why it's also classified as a near-Earth object. Bennu is a carbon-rich asteroid that was formed in the first 10 million years of the history of the solar system. That's around 4.5 billion years ago. No wonder this space body holds precious clues to the origin and development of the rocky planets of our solar system, which are, as you recall, Mercury, Venus, Earth, and Mars. Even better, it may contain organic molecules, similar to those that are crucial for life to evolve. In 2020, NASA's OSIRIS-REx managed to briefly touch the surface of the asteroid. It collected some samples and propelled off the space rock afterward. For NASA, it was the first mission of this kind. But it won't probably come as a surprise that Bennu isn't the only asteroid we should worry about. Asteroid 99942, Apophis, is another space body we'd better watch out for. It's a near-Earth object about 1,100 feet across. It was discovered in 2004, and at first, it was identified as one of the most dangerous asteroids ever detected. Apophis gained notoriety very fast. It was believed to pose a serious threat to Earth. Experts predicted that it would come uncomfortably close to our planet in 2029. Luckily, after a more careful examination of Apophis and its orbit, astronomers concluded that there was no risk of the asteroid colliding with our planet for at least a century. The risk of an impact in 2029 was ruled out completely, as well as the potential impact that could be caused by the asteroid's close approach in 2036. Interestingly, until March 2021, there was a small chance of a collision in 2068. But then Apophis made a flyby of Earth, and astronomers took this chance to use powerful radars to estimate the asteroid's orbit around the Sun more precisely. This allowed them to rule out any impact risk for at least the next 100 years. Now, the reason why such discoveries make us so worried is that even a relatively small asteroid, the size of a house, can wreak havoc upon colliding with our planet. And if an asteroid is larger than 0.6 miles across, astronomers call it a planet destroyer. The impact energy released by such an asteroid after striking Earth could be devastating. That's why knowing where such asteroids are and in what direction they're moving is crucial. The problem is that our capability to protect the planet from asteroid impacts is not top-notch yet. If such a catastrophe was about to occur, we would need some time to prepare, because an asteroid collision is no joke. Probably the most well-known asteroid impact site is the Chicxulub crater. It's the evidence of the terrifying collision that led to the extinction of dinosaurs. Strangely, this crater isn't very visible, but some others are. For example, Barringer Crater in Arizona, which is also called Meteor Crater. It looks rather blood-chilling when you think about the collision that led to its appearance. In any case, we now know that space rocks hit not only the Earth but also the Moon, Mercury, and Mars. No rocky planet in the solar system is safe from asteroid impacts. That's why we have an entire scientific enterprise whose goal is to find and catalog the asteroid population of the solar system. Now, it might sound a bit scary, but there are around 25,000 asteroids larger than 460 feet in diameter near the orbit of our planet. Such a space rock is large enough to wipe an entire city off the face of the Earth. So far, less than 50% of such asteroids have been detected and tracked. There are also an estimated 230,000 objects equal to or larger than 160 feet in size. Those are capable of destroying a concentrated urban area, and still fewer than 8% of those have been detected. There are also tens of millions of smaller near-Earth objects. They are larger than 33 feet across and might cause some surface damage. Less than 1% of such small space bodies have been discovered so far. Now, the thing is, the inner solar system is extremely challenging for asteroid search. Each night, there are only 2 10-minute windows when astronomers can observe the region, all because the sun's glare creates a very bright background glow. Plus, the atmosphere of our planet also distorts and blurs observations. Spotting asteroids in such conditions is beyond the capabilities of most telescopes. A unique instrument is needed to fulfill this task, and the tool of choice is the Dark Energy Camera at Cerro Tololo Inter-American Observatory in Chile. This device wasn't designed to hunt asteroids. Researchers built it to search for another elusive target, dark energy, the mysterious force driving the expansion of the universe. The DEC is supposed to observe hundreds of millions of galaxies. That's why it's both wide and deep. This way, it can both peer deep into the universe and capture a wide field of view, which helps it record the motions of galaxies and the conditions in the early age of the universe. But it also means that the DEC is perfectly suited to spotting asteroids near the Sun. Inner asteroids are rare, and deep images are necessary because such asteroids are faint. Scientists need to be able to fight both the bright twilight sky near our star and the distorting effect of Earth's atmosphere, and the DEC can help them achieve their goal. The Dark Energy Camera was built to carry out the Dark Energy Survey, which finished in 2019. Now astronomers can direct the power of the camera towards other tasks. They claim that the DEC's survey is one of the most sensitive searches ever performed for objects near Venus's orbit and within the orbit of our planet. It provides us a great chance to find out what kinds of objects are lurking in the inner solar system. So, dark matter is a mysterious substance that makes up about 85% of the total matter in the universe, yet we can't see it or touch it. The regular matter that we're used to forms stars, planets, and everything around us. But dark matter doesn't emit, absorb, or reflect light, which is why we can't even see it. We don't even know if it actually exists. The reason why we believe in dark matter is because it leaves gravitational effects on galaxies and other cosmic objects. For example, spiral galaxies spin in a way that doesn't match the law of physics we know. According to our current knowledge, the outer edges of these galaxies should slow down, but they don't. They either keep the same speed or even speed up. It also seems to be acting like an invisible glue that holds galaxies together. If dark matter didn't add some invisible gravitational mass, the galaxies would literally break apart, not being able to hold stars together. But even though it's fundamentally important for our world, we still don't know exactly what dark matter is made of. This has been going on for years. Some experiments saw hints of it, but no one's been able to prove it beyond a doubt. Maybe the future Circular Collider will be able to find it. There's a mysterious force in space that seems to be pulling our entire galaxy, along with many others, toward it. This force is known as the Great Attractor, wink wink. It's a crazy massive region in space, about 10 million billion times the mass of our Sun, with a super powerful gravitational pull. Scientists think it might be a super cluster of galaxies, but they're not sure. The problem is, we can't see it directly because it's hidden behind the Milky Way, while the Milky Way itself, horrifyingly, is moving toward it at a speed of about 370 miles per hour. Now, just like with dark matter, we only know it's there because of how it affects the movement of galaxies around it. These galaxies are being pulled toward this region, even though, since the universe is expanding, they should be moving away from each other. What's even weirder is that this great attractor might itself be moving towards something even bigger, the Shapley supercluster. It's the largest concentration of galaxies in our nearby universe. In 2017, astronomers discovered a strange object called Oumuamua. This was the first known visitor from another star system. The thing was quite small, from about 330 feet to about 0.6 miles long. It was also long and thin, had a reddish color, and moved in a very unusual way. As it passed by the Sun, it unexpectedly sped up and then left our solar system just like that. Tons of theories started sparking up. It was too weird looking for an asteroid. Scientists thought it might be a comet, but it didn't have the usual traits of one, like a tail of gas and dust. Eventually, some scientists even started to suggest the wildest theories, like it might be an extraterrestrial probe. People have been making a huge fuss about Oumuamua ever since. But after a while, it turned out it was just a natural object with unique properties. It was probably a fragment from a distant star system, like a piece of a disintegrated comet or even a chunk of a planet. But Oumuamua caught everyone's attention so much that in 2022, astronomers even proposed to send a spacecraft to catch up with it. This mission could take about 26 years. Hey, stay tuned. Now, as for extraterrestrial creatures, where is everyone? There's this thing called the rare Earth hypothesis that suggests that life as we know it is actually super rare in space. In the 70s and 80s, scientists argued that Earth is just an ordinary planet in an ordinary solar system. If we look at it this way, life should be widespread across the universe. It seems unreasonable to think that with trillions of planets out there, there will be no planet like ours anywhere. But then, a geologist, Peter Ward, argued that the development of complex life like ours depends on a very rare combination of things. The history of the planet, with all of its astrophysical and geological conditions, should line up perfectly for complex life to develop. So, just think about it. Being in the right zone of the galaxy, on a good distance around a stable star, a rocky planet with water and the right temperature, emergence of molecules, monkeys deciding to walk, and so on. This would explain the Fermi paradox, which asks, if extraterrestrial life is common, why haven't we seen any signs of it? Well, the rare Earth hypothesis explains it. The universe might be full of plants, extraterrestrial critters, and fun animals. But would there be an intelligent species like humans? That's another story. As for humans being intelligent, that's another matter. Dark matter? And even if they do exist, we could be incredibly far away from each other. That would make communication or contact with other intelligent species very unlikely. Now, there's another similar theory called the Great Filter. This idea says that there might be a big obstacle somewhere along the path from microbes to advanced civilizations. It was the idea of the economist Robin Hanson. He also believed that maybe intelligent life, as we know it, isn't that common in the universe, although he assumed it's not because our planet was the result of tons of unique conditions, but because there must be some sort of filter that reduces the chance of life progressing to our point. Who knows where this filter is? It might be in the stage of early microbes, which means that we managed to get through it or somehow ahead in the future, which means we might go extinct like many other species before us. Well, maybe in the next stages, such as colonizing other planets and the galaxy, are much harder, if not impossible. Something unexpected might come up, potential catastrophes, resource exhaustion, or other challenges. Now, there's this thing called a pulsar. It's a weird type of star that sends out regular bursts of radio waves, like a flickering space lighthouse. You see, in space you often find a pulsar and a smaller companion star that rotates around it. But one day, scientists discovered this system, which was also surrounded by tons of some energetic material. They suddenly realized that these are probably the remains of another companion star, which was very big in size. But the pulsar was blasting out powerful radiation and particles, slowly consuming its companion. This is kind of like how a black widow spider eats its mate, hence the name. Since then, they've found other similar systems. They've grouped them all into one spider family. There are also redback pulsars, which destroy slightly larger companions, and huntsman pulsars, which have companions that are massive enough to resist being completely destroyed. Even though so many safety measures are taken, space is still an unpredictable place where we don't have as much power as we'd like to. Back in 1973, during a spacewalk on the Skylab space station, 2 astronauts were in a very risky situation. They were out in space fixing things, but they didn't have the same handy jetpacks like astronauts do today. They could only rely on safety tethers. Suddenly, the solar arrays they were working on moved unexpectedly and pushed them out of their position, almost sending them drifting off into space. Thankfully, the safety ropes did their job. Strong, resistant to heat, and attached to astronauts' waists, these tethers can hold a weight of about 881 pounds. This accident happened before SAFER came into use. It's easy to understand why accidents at work are way scarier up there than some regular 9-to-5 job on Earth. But that's why you have more training and special equipment to keep you safe. First, astronauts are always attached to the spacecraft with tethers, so they don't float away like a helium balloon. It may seem like a spacewalk is such a big deal that the ISS needs to stop when the astronauts are out there doing their thing, but it's not like that. If the ISS were ever to stop, it would fall straight down to our planet. So, once an astronaut is in a stable orbit, they stay in that orbit, unless some new force acts out. The first spacewalk wasn't as simple as those done later. It was performed in 1965, and it lasted 12 minutes. 2 men set out on a mission. One of them was supposed to float in space for a while taking pictures. But things went wrong. His spacesuit expanded too much, making it hard to move. He started to feel overheated, so he had to let some oxygen out of his suit, which was very risky. He could run out of air or get sick like a deep-sea diver. Getting back into the spacecraft was tough as well, but he somehow managed to do it. Then, more problems came. The spacecraft started spinning, oxygen levels rose dangerously, and there was a risk of an explosion. After a lot of struggle, they made it back to Earth, but landed in a random forest surrounded by wolves and bears during a snowstorm. It took a rescue party to find them. Not a very encouraging story to listen to while you're waiting to go out. But cheer up, things have improved since then. Hundreds of astronauts have taken spacewalks without any serious problems. So here you are, whizzing right along with the giant ISS. Your first spacewalk goes almost flawlessly, so you can enjoy the view a bit. It's hard to control the way you move, but tethers still do their job, so you can focus on your task. Until you realize they failed. How did they untie? You notice you're floating off in some random direction. There's nothing you can hold on to. Your body is weightless, and it has started to spin around. It's so frustrating when you can't take control of your movements. An astronaut named Scott Kelly described this unpleasant feeling in his book Endurance. He was turning around and upside down in the darkness and could see nothing but what was right there in front of his face. It was like a scuba diver floating in murky waters, totally disoriented, with no way of telling which direction was wrong and which one could be right. In space, you can't kick or flail to change your course. It might be fun floating inside a spacecraft with zero gravity, playing and fooling around, but seeing just the endless void filled with stars in the distance and knowing what could happen makes it frightening. And now you're getting closer to Earth's atmosphere. It might seem like the safest option because it makes you feel like you're going home, but in reality, you better hope you'll change direction. If your angle and speed are wrong, you might re-enter the planet's atmosphere and burn up. Not a good deal. NASA trains astronauts for such situations, so you know what's your next step: activating an emergency jetpack called SAFER. This tool is designed to help you stabilize and move in space. You don't even need the tethers. You can control the movements of your jetpack with a small joystick. Finally, all those hours of playing video games will pay off. These jetpacks became an inevitable part of the spacewalk package almost 30 years ago. So far, no astronaut has had to use one during a spacewalk. Whew! You're back on track, and you're moving away from Earth's atmosphere. You're getting closer to the ISS, flying manually. Oops! These jetpacks have one big flaw. They have a limited amount of fuel, and your SAFER has just run out of it. Okay, take a deep breath. One of the most important things every astronaut has to learn is to be prepared for literally anything. This strange radio signal wasn't found by a scientist on a serious mission. It was actually discovered by a college student just doing a regular project for school. Tyrone O'Doherty, an undergrad student at Curtin University in Australia, was sifting through old data of the southern sky. He was looking for any weird blinking radio signals. He finally stumbled upon one from 2018 that seemed to shoot radio waves towards Earth like a lighthouse beam. Excited about his find, Tyrone shared it with his mentor, radio astronomer Natasha Hurley-Walker. She dove into researching this signal, hoping for a breakthrough. But despite checking different frequency data, they hit a dead end. But then, Natasha spotted a pattern. The signal repeated every 18 minutes. This was huge. But just as they were gearing up to study it further, poof! The signal vanished after only 3 months, leaving them with nothing. Not giving up, Natasha and her team scanned the skies again, desperate for a clue. Months passed, but nothing turned up. They were ready to give up, and then suddenly, a new signal popped up. This one kept blinking for 5 minutes, then it disappeared. And then it came back exactly 22 minutes later. The main question was if that signal was related to an 18-minute one. To figure it out, Natasha went back to the old radio data from that area. As they dug deeper, they realized that yes, and these signals aren't anything new. They've been beaming towards Earth for 35 years. Back in 1988, Indian and American telescopes had caught them, but they got buried under tons of other data. This was great news for space explorers because it meant they could now calculate how far away this mysterious object was. After doing the math, they figured out it was incredibly far, even on a space scale, 15,000 light-years from Earth. Now, the only thing left to uncover was what exactly this object was. Walker and his team started comparing it to all the known radio-emitting objects out there. Yet its source remains a mystery. The signals still pop up every 22 minutes on NASA screens, always ending with a frustrating match not found message. The scientists called it J183910. Some think that the signal might come from some extraterrestrial beings. Maybe it's the signal that SETI, the search for extraterrestrial intelligence, has been waiting for. This project has been working for over 50 years, trying to find any evidence of life beyond Earth. They also scan the skies for radio waves, laser pulses, and other mysterious signals. So maybe it's a way for extraterrestrial folk to communicate their location. Over billions of years, the surface of the Moon has been hit by asteroids and comets, causing bits and pieces to constantly break off from the impacts. Because of this, all the surface material is pretty loosely packed. So when there are quakes, slopes in the same area can become susceptible to landslides or new faults opening up. Future settlements located too close to these unstable slopes could put everyone living inside these lunar bases at risk. Moon dust adds another layer of complexity because, without erosion or water to smooth it out, it can harden to the point of being as tough as glass. If we really want to understand how dangerous moonquakes might be for people living and working on the Moon in the future, space agencies still need to map out and get new seismic data, and not just from the South Pole, but from the entire satellite. In 2025, the Farside Seismic Sweep Mission, or FSS, plans to deploy two of the most high-precision seismometers ever built to the Schrödinger crater, which is located on the dark side of the Moon. Finding out what's happening on the ground there is crucial for understanding the complex lunar structure and its internal dynamics. Scientists are still trying to figure out whether the lack of recorded seismic activity on the far side of the Moon is due to current instruments not being capable of detecting it, or if it's due to some kind of interference from melted material in the mantle. Once they have this answer, it will be easier to fully understand the phenomenon of shallow moonquakes and assess their implications for future neighborhoods on our natural satellite. Now, you may have heard that Earth is also shrinking, but it's a different process. Basically, the Moon is getting smaller mainly because its core is cooling down naturally. The Earth's core is cooling too, but our planet got its crust with tectonic plates, unlike the Moon, which only has one plate. So the energy from Earth's core shifts those plates around or comes through volcanic eruptions. Earth is actually losing mass overall due to atmospheric loss. Our planet loses about 100 million pounds of mass per year, mostly from a leaky atmosphere. Earth's gravity isn't strong enough to retain the lightest particles, like hydrogen and helium, which escape into space. But don't worry, these numbers aren't cause for alarm, considering that our planet's atmosphere weighs about 5 quadrillion tons, a number I can't even imagine. So, in other words, it would take many, many, many times the current age of the universe for it to completely evaporate. We found a water cloud in space around a black hole. It's a gigantic water reservoir that's located about 12 billion light-years away from Earth. This must be the largest and farthest water reservoir ever detected in the universe. This one cloud contains an astonishing 140 trillion times more water than all of Earth's oceans combined. That's wet. The water surrounds a quasar, which is basically an incredibly energetic supermassive black hole. This quasar is about 20 billion times larger than the Sun and emits as much energy as 1,000 trillion suns. You do the math. As the black hole slowly consumes everything around it, it releases energy. This energy heats the surrounding gases and dust, causing the formation of water vapor. As a result, the black hole is surrounded by a huge water cloud and all the other gases and dust bath around it. This pair formed when the universe was only 1.6 billion years old, just a fraction of its current age. That means that the water isn't young at all and has been existing in galaxies for billions of years now. This quasar will only keep getting scarier and bigger. If it eats up all this gas and dust around, it could grow up to 6 times its current size, potentially becoming 120 billion times larger than the Sun. Think about that. Ruh-roh, there might be another universe, like a dark mirror image of ours, where time flows in reverse. This flipped-over world might also be the source of dark matter, the invisible substance that's all over our universe. There might also be many more universes out there, in which an exact copy of you woke up this morning, but it chose a white t-shirt instead of a red one, sending it on a completely different life path. But let's start with this elusive dark matter. It makes up most of the universe's mass, yet we're not sure what exactly it does or where it comes from. That's because it doesn't act like regular matter. We can't see it or feel it. We just know it's there because of how it seems to bend gravity. Even though regular matter and dark matter are very different, they seem to exist in a balance. Some scientists think this must be connected somehow. A new theory suggests that for every way regular matter moves, There's a mirror version of it in the world of dark matter, like a bridge connecting the two worlds. There's also a strange coincidence in regular matter where a neutron and a proton have almost the same weight. This allows them to stick together and make atoms stable, making everything that we can see with our eyes exist. If protons were a bit heavier, there would be no balance and atoms wouldn't form. In the dark mirror universe, maybe things happen differently. Maybe in there, the equivalent of a proton doesn't bind to other particles, leaving behind lonely neutrons, which could be the source of dark matter. This theory also suggests that dark matter might have its own chemistry, like dark atoms and a dark periodic table. For the longest time, scientists believed there was just one type of dark matter. Although these particles are similar in some ways, like being almost invisible, they may vary in their sizes, speeds, and how they affect regular matter. If this idea is right, it means there could have been interactions between our universe and the dark mirror universe in the past. Studying how elements formed in the early universe might give us clues about this. The idea of a flipped world has sparked curiosity and even some confusion in the scientific community in recent years. Astronomers use a theory called the lambda CDM model to explain the composition and behavior of our universe. According to it, most of the universe is made of two things: dark energy and dark matter. Dark energy is like the pushing force that makes the universe expand faster. Dark matter is this invisible thread that pulls things together with its gravity, acting like a universal glue. Regular objects, like stars, planets, and comets, only make up a small part of the mix. The model also tells us about the Big Bang, and how everything started from a hot, crowded beginning, and how the universe has been growing and changing ever since. While this model seems to be correct in many ways, it doesn't explain all cosmic phenomena. If you were to draw this model on a piece of paper, it would look like a series of flat pancakes stacked on top of one another. Each one of the pancakes represents a rendition of the universe at a certain point in time. Yesterday's universe would stand below that of today, but it would be a slightly smaller pancake. By the end, you'll see that the universe's history looks like this giant upside-down cone, with its minuscule tip being the Big Bang. Beyond this point, we can't see any further away in time with the tools we have, so we don't know what's beyond. More so, we're still not even sure what happened immediately after the Big Bang. But if we simply apply the math, the universe might go beyond this historical tipping point, which could mean it could go in reverse, creating a similar mirrored cone where time would flow backwards, in our perspective at least. This alternative idea not only challenges our understanding of cosmic origins, but also raises questions about fundamental principles in physics. All the excitement around a mirrored universe also came from ANITA, a scientific instrument stationed in Antarctica, and its discoveries. This device saw some weird high-energy particles seemingly bursting from beneath the Antarctic ice. The problem with these particles is that they didn't behave as the laws of physics dictate. Scientists think they have a type of cosmic rays. They travel from space through the Earth and back out again. But the particles we already know about shouldn't behave like that. That's because higher energy particles usually collide with something inside the Earth and don't come out the other side like these do. They seem to be doing things both forward and backward. For now, there's no concrete proof of a mirrored universe. These particles could simply be ones we haven't discovered before, and scientists need to study them closely to come up with a definitive answer as to why they're behaving like this. Kind of like 4-year-olds. But what if there isn't just one other universe, but many more? This multiverse concept comes from ideas like the inflation theory, which says that our world had this rapid expansion in its early stages. While inflation stopped in our neighborhood billions of years ago, it's likely that it continues in other regions of the multiverse, creating different universes with their own laws of physics and unique characteristics. Our universe is the only one that we know of that can support life. We have stable stars that can provide heat and warmth, for example, which is crucial for creatures to start moving around. We also have an abundance of elements like carbon and hydrogen, which we also need to exist. The multiverse hypothesis gives an explanation for why our universe exhibits such life-friendly conditions. It may explain that there are countless other universes out there, with varying conditions, making the existence of life in at least one of them less likely. One fascinating implication of the multiverse theory is the idea of doppelgangers, these exact copies of individuals existing in parallel universes. This notion suggests that within the vast expanse of the multiverse, there could be infinite scenarios where identical versions of ourselves are experiencing similar events at the same time. Before we begin our travels to different universes altogether, we might need to understand our own. There's this galaxy, for instance, far from us, that might have no dark matter at all. It's about 250 million light-years away and looks normal at first glance. But if we look closer, we can't seem to find any dark matter. If it turns out that there are more galaxies like this one, it could change our ideas about how galaxies are made. Dark matter is usually thought to be necessary for this process, acting like the glue that holds the whole thing together. It is true, however, that this particular galaxy is more faint and has fewer stars than usual. When it was first discovered in 2019, scientists thought it might not have dark matter because of how fast it was spinning. The speed at which a galaxy spins tells us how much stuff there is in it. By comparing this speed with what we can see, astronomers can figure out how much extra stuff, like dark matter, must be there. And in this unique galaxy, the math says there isn't any. Among all these theories, there's also one that says dark matter might not be real at all. This new study proposes that maybe we've been looking for something that doesn't even exist. They think that our understanding of gravity might not be good enough to explain why some galaxies behave oddly. So instead of dark matter causing these weird behaviors, they say it might just be that we don't fully understand how regular matter works. They base these findings on a theory called modified Newtonian dynamics. It suggests that gravity behaves differently at very large distances or very low speeds. Space travel has come a long way since Sputnik was launched into orbit in 1957. Since then, we've sent humans to the moon, set up the International Space Station, and even sent robot spacecrafts to explore other planets. But there's still lots more to discover and achieve in space. So, what are our current plans? What technologies are we developing now? And what awaits humanity in the next 100 years? Let's find out, shall we? First of all, artificial intelligence. Fun fact, my high school history teacher claimed this is what I had as per my test scores. Right now, humanity is actively engaged in the development of artificial intelligence, and we've already made a bunch of breakthroughs in this area. With the help of AI, we're going to be able to explore the cosmos like never before. Think about it. AI can automate and optimize tasks like mission planning and data analysis. Now, human astronauts can focus on more important things, like looking for some non-human astronauts. Plus, AI can control and operate spacecraft remotely, reducing the need for risky human missions. And that's not all. This super smart technology can also provide unique perspectives and insights that humans might have missed. AI could also help us understand the data collected by space probes. In short, the use of AI in space exploration will help us learn more about the cosmos and make exploration more efficient and cost-effective. And this isn't the only thing that will help us in conquering space. Next, reusable rockets. Gone are the days of one-time use rockets. These days, reusable rockets are taking over the space industry. Not only do they save money, but they also make space travel more accessible to a wider range of people and organizations. To date, the SpaceX company has created a bunch of reusable rockets, like the Falcon 9 and Falcon Heavy. They've completed many successful missions to the International Space Station and beyond. Blue Origin has also made great progress in reusable rocket technology with the New Shepard. It's even planning to take paying customers on trips to space soon. Alright, so these cool technologies will help us get up there. But what are we going to do next? Moving on to building settlements beyond Earth. Space colonization, here we come. The possibility of establishing colonies on other planets, such as Mars, is a dream that has captivated humans for decades, and now it's finally within reach. But before we start packing our bags, here are a few obstacles we need to overcome. For starters, getting to Mars is no easy feat. It's a long journey that could take months, if not years. So first, we need to figure out how to keep humans alive and healthy during the trip. Now, once we get there, we'll face even more challenges. The harsh radiation and extreme temperature fluctuations are just a couple examples. Living and working in space isn't easy either. We need to make sure that everyone has what they need to survive. It's not like you can just go to the store for supplies. So we'll have to build systems to provide food and water, create some advanced transportation, and maintain all of that in good condition somehow. Finally, let's not forget about the most important thing: money. Building and maintaining a settlement beyond Earth is no small feat, and it will take a lot of resources and cooperation to make it happen. But there are still great benefits in living in space. It opens up many opportunities for scientific research and exploration. We'll be able to learn more about the universe and our place in it. So, no dream too big. Even though it's a big challenge, it has the potential to be really rewarding for humanity. That's why private companies and space agencies are already working on plans to send humans to Mars and potentially even terraform the planet. Actually, let's talk about that. Terraforming. The dream of turning a barren, inhospitable planet into a habitable paradise. Sounds like something straight out of a sci-fi novel, right? Well, believe it or not, by using advanced technology and resources, we could potentially turn deserts like Mars into beautiful Earth-like worlds. But here we also have a few hurdles to jump through first. Terraforming isn't exactly a quick process. It would take lots of time and resources to make any significant changes to a planet. There are also some ethical dilemmas to think about. If we start trying to change the Martian ecosystem, we could potentially wipe out any existing life forms. Imagine if someone did that to us. Actually, we've been doing it to ourselves. And finally, there's the cost. Terraforming would be a major expense, and it's not clear who would foot the bill. It would likely require the cooperation of multiple countries and organizations. But even with all these challenges, this is still an exciting prospect. Who knows? Maybe one day we'll be able to turn Mars into the ultimate vacation spot. And that's just the beginning, because we won't stop at Mars. Our next goal is asteroids and other celestial bodies. Now picture this: you're floating in your spacesuit, mining an asteroid for some seriously valuable resources. You strike gold, or rather a shiny vein of platinum, and head back to Earth to sell it for a fortune. And with the money, you fund even more space mining expeditions, becoming the ultimate space tycoon. But seriously, space mining could be a game changer for space exploration and the economy. Imagine being able to extract water from asteroids to sustain human settlements on other planets, or mining rare minerals to use in high-tech industries back on Earth. The economic benefits could be massive. Of course, there are also challenges to overcome. We'll need to figure out how to safely and sustainably extract resources from asteroids. We also need to make sure that space mining is done in an ethical and fair way. But once we deal with all this, it'll change our lives forever. So let's get to work. But once we've mined everything, what awaits us next? For example, what lies beyond our solar system? Interstellar travel and the search for life. We've already made some amazing discoveries in our hunt for extraterrestrial life. For example, NASA's Viking landers and the Galileo spacecraft have given us some clues about it. Also, in 2022, we found traces of organic matter in the former Martian lakes. We're not sure yet, but perhaps Mars was once as prosperous as Earth. But we all know that the real excitement lies beyond our solar system. Scientists have already found thousands of other distant exoplanets, and some of them are in their star's habitable zone, meaning they could potentially support life. So our next step is to send probes or even humans there. Imagine being the first person to set foot on another planet, discovering microbial life, or maybe even a more advanced civilization. Talk about out of this world. And maybe, one day, traveling to another star system will be like a regular road trip, except instead of a minivan, you're in a spaceship. And instead of stopping at a rest stop, you're stopping at a new planet. Sounds awesome, doesn't it? Right now, there are a few ideas about how we might make interstellar travel a reality. One possibility is the use of wormholes. These hypothetical tunnels in space-time could potentially allow us to travel vast distances in a shorter amount of time. It's like taking a shortcut, except instead of cutting through someone's backyard, you're cutting through the fabric of the universe. Pretty crazy, huh? Another option is antimatter propulsion. This involves using antimatter, which is the opposite charge of our regular matter, as fuel for a spacecraft. When it comes into contact with regular matter, it releases a huge amount of energy. Imagine your car's gas tank being filled with antimatter instead of gasoline. That's going to be a powerful ride for sure. Of course, there are still lots of challenges to overcome before we can make interstellar travel a reality. But let's hope that one day we'll all be able to pack our bags and hop on a spaceship for a trip to the stars. Anyway, the future of space travel is looking bright. With all of these advancements in technology, we're excited to see what feats of exploration the future holds. No one will hear your cry in space, or something like that. We've all heard this famous chilling phrase, and it's actually true. Space, for the most part, consists of a giant nothingness. There's a lot of, space in space. But this doesn't mean there are no sounds in space. In fact, there are plenty of them, and some of them can even make you shiver. Let's take a look at the scariest space sounds. First of all, how are cosmic sounds even recorded? Sound is just the vibration of molecules. When you scream, you make the molecules push each other furiously until they reach the ear of the person you're yelling at. Then these vibrations get transmitted to the brain, and we recognize them as something that you might need to apologize for. In other words, to hear something, we need molecules. And that's where things get complicated. There aren't any of them in space. The entire universe almost completely consists of a vacuum. No, not a Hoover. Absolute nothingness. However, the wizards from NASA still record space sound somehow. So how do they do it? The thing is, there are some types of waves that don't care about molecules. We regular folk can't perceive them without some special devices. These waves include, for example, radio waves. We'll need a radio or something like that to recognize them. And that's exactly what NASA's satellites do. They catch random radio waves. Thanks to their heroism, we can find out how different cosmic bodies sound. These satellites record a variety of waves, fluctuations of plasmas, magnetic fields, and other, stuff. And then scientists from NASA transform all this into normal soundtracks. And some of them sound quite frightening, to put it mildly. Let's take our magnetic field, for example. It surrounds our planet like an invisible shield, protecting us from all sorts of nasties, like radiation and solar winds. At the same time, we can neither see it, feel it, nor hear. Oops. Well, the last one is outdated. Scientists from the Technical University of Denmark took magnetic waves recorded by the ESA swarm satellite. They converted them into an audio track and got a pretty creepy result. Now, to be honest, it sounds more like an eerie entity stalking you in the middle of the night. And if you remember the maps of Earth's magnetic field, it starts to feel like a spider crawling nearby. Ew. And this isn't the first strange sound that we caught on Earth. Recently, we caught another weird radio emission from space. Scientists found out that the repeating signal came from somewhere very far away, like billions of light years away from us. Such fast radio bursts usually lasted no longer than a few milliseconds, but this one was unique. It lasted about 3 seconds, basically thousands of times longer than usual. And at the same time, the signal was very precise, so much so that scientists even compared it to a heartbeat. Scientists believe that this signal is caused by pulsars, or neutron stars. One time, Nikola Tesla caught something similar, but unfortunately, at that time, we didn't know about such things as pulsars, so Tesla was sure that he had caught a message from some extraterrestrial life. It's a pity that the truth turned out to be much more boring. But let's move on from the Earth to the Moon. In 1969, the astronauts of the Apollo 10 mission, the spacecraft that made the final test flight to the Moon, flew past its surface. And then they caught some strange signals coming from the dark side of the Moon, the side that we never see because the Moon is tidally locked to us. The sound was so weird that the astronauts weren't even sure whether to report it to NASA. They were afraid they wouldn't be taken seriously, and maybe even not allowed to participate in the next space missions. Here's what it sounded like. But according to NASA, it's not some creepy extraterrestrial music at all. These may just be some radio waves that affected each other because of their proximity, although the astronauts who heard it for the first time probably felt a little creeped out. Let's move to the other planets. Now, 40 years ago, scientists actively explored the surface of Venus. They sent as many as 10 probes there, which were supposed to capture audio and video shooting from the surface. Now we know what Venus, which could easily destroy us at any attempt to even get close to it, sounds like. Horrifying. And you wouldn't expect anything else from the most dangerous planet in the solar system. Unfortunately, Venus is even more toxic than the average Twitter user. So these probes didn't last too long. They heroically arrived on a planet and soon broke down. Next one is Jupiter. This space giant, which is 11 times larger than the Earth, never fails to scare us. One of NASA's probes, Juno, flies around Jupiter every few weeks. The probe is moving at a tremendous speed, 130,000 miles per hour. One day, Juno caught one of the strongest invisible signals it had ever encountered. This was the point at which the mad solar wind came into conflict with the magnetic field of Jupiter. It kind of sounded like a cosmic boom. The original sound lasted 2 hours, but it was compressed to a few seconds. It actually sounds more like a collision of a sea wave and a rock. But here, in terms of horror, Jupiter surprisingly loses to one of its small moons, Ganymede. In 2021, the Galileo space probe flew past Ganymede, and during its flight, it received a rather strange recording. These sounds are satellite radiation, and it's unclear whether it sounds like a cozy sunny day in the jungle or like thousands of bats waiting for you in the night. Next one is Saturn. This signal was caught by the Cassini-Huygens Automatic Interplanetary Station, which was launched into space in 1997. When flying past Saturn, Cassini recorded a pretty scary sound. This terrifying cry of thousands of souls is actually just some radio waves. They aren't too different from what the auroras emit on Earth. A little later, Cassini received another recording, the sounds made by lightning and thunderstorms on Saturn. They sound pretty interesting too. More like popping corn or a Geiger counter, right? But that's just because these lightning strikes have a crazy frequency. Moving on from the solar system to outer space. The famous Voyager 1 was launched back in 1977 and continues to send us data even 40 years after its launch. In 2012, it left the solar system and entered interstellar space. And then, while abandoning its home, Voyager 1 detected the sound of plasma waves. The original recording lasted 7 months, but fortunately, scientists felt sorry for us and reduced it to 12 seconds. It isn't really eerie, but is still kind of unsettling. And although it feels like nothing can beat Saturn's horrors, let's end this tournament with one of the scariest objects in the universe, a black hole. This sound was recorded by the Chandra Space Telescope. While studying a cluster of galaxies in the constellation Perseus, they discovered something strange. Some undulating movements appear from the center of the cluster. They spread out in all directions, like circles on the water. Scientists have suggested that this was caused by a supermassive black hole. The thing is, black holes don't always devour space objects entirely. Sometimes they kind of spit them out. This causes vibrations of gases, which we can convert into soundtracks. What's interesting is that the oscillation of each such wave actually lasts about 10 million years. You're just listening to a very accelerated recording. Scientists have reduced the delay between oscillations by about 144 quadrillion times. So let's check it out. This is probably the eeriest sound from the whole list. Nothing too loud or wild, but there's something dark and disturbing about it. Now, those were the scariest space sounds captured by NASA. To be fair, most of them sounded creepy simply because they're radio waves, but it's still fun to get spooked sometimes.
Two pictures are rapidly changing in front of your eyes: our huge planet and a black void. The picture of Earth is getting smaller by the second. You're flying away from the spaceship into an endless vacuum and don't know what to do next. The International Space Station flies 250 miles above Earth's surface. A spacewalk is routine for astronauts who work there. Astronauts have spent more than 11,000 hours in the black abyss to this day. Fortunately, during all this time, no one has ever flown away into outer space without coming back, as we've seen in the movies. But unfortunately, astronauts face other, no less terrible, dangers during spacewalks. One such accident happened in 1966. Eugene Cernan put on a jetpack and went into outer space to carry out some repair work. The jetpack, which helps an astronaut control flight in zero gravity, heated up a lot. Eugene put on special protective pants made of metal to protect himself from this heat. The pants protection didn't work when he went into outer space. Instead of directing the heat away from his body, the pants began to heat up. The suit was heavy and uncomfortable, like a knight's armor. It rubbed his skin and restricted movement. Working in zero gravity is physically very hard, but Eugene also had to deal with his whole suit heating up that day. Inside the spacesuit, he felt like he was in a hot bath. High temperatures and hard work caused overexertion, dehydration, and severe weight loss. His face was sweating, and drops of sweat blinded him. During this spacewalk, the astronaut lost about 13 pounds of weight. Other astronauts came to the rescue and took him back to his spacecraft. To reduce overheating, they sprayed him with cold water from a hose. In a sense, to go out into an infinitely huge open space, an astronaut must put on a suit resembling a body cage. Another dangerous incident happened in 1973. Two astronauts, Pete Conrad and Joe Kerwin, went into outer space to repair a solar wing on the Skylab space station. The wing didn't turn around, and the astronauts tried moving it manually. Using force, they turned the stuck wing, but it pushed them. The push was so strong that it threw both astronauts aside. They didn't have time to grab onto a nearby surface and began to fly away into outer space. Fortunately, they had safety cables that didn't let the astronauts go away for good. By grasping them, the astronauts returned to safety. In an ordinary modern spacesuit, there are more than 10 protective layers. Such a suit protects against extreme cold and hot temperatures. It's tear-resistant and doesn't leak moisture from the outside. This protection is necessary to prevent depressurization. If a small passage appears between your body and space, then all the oxygen will start coming out of the spacesuit. The more oxygen the suit loses, the more vacuum it gets. This leads to terrible consequences, such as suffocation and increased body volume. It looks as if you start to inflate from the inside. In 2007, Rick Mastracchio went into outer space to do some repair work. For some reason, there was a hole in his left glove next to his thumb. It was on the outer layer of the glove. But the worst thing was that the astronaut hadn't noticed it. He continued to work as if nothing had happened. but one damaged layer could destroy the second. The second one could tear the third one, and so on, until the vacuum reached the astronaut's skin. Rick was supposed to work 6 hours in outer space, but during the 4th hour, he noticed the damage in his spacesuit. The astronaut reported this to command and received an urgent order to return to the ship. He never found out how the hole had appeared. Inside the ISS, there are many chemicals necessary for working in space. For example, ammonia has the property of freezing almost any surface. This chemical frost is used to cool some components of the station during overheating. The leakage of this substance on the ISS is practically impossible. This is exactly what astronaut Robert Curbeam heard from experts during the training before his first flight to space. But this accident occurred to him on his first spacewalk in 2001. Robert was working outside the space station when an ammonia leak started. The liquid splattered all over his spacesuit. A thick layer of ice quickly covered the glass. Robert didn't see anything. He feared that he had broken something, but the accident was not his fault. The protective layers of the spacesuit didn't allow Robert to freeze, but the ammonia severely restricted his movements. The main problem was that he couldn't return to the ship. Ammonia could get into the station, and this could lead to an emergency. Robert had to stand in outer space for 1.5 hours and wait for the leak to end. After that, he successfully returned to the station. To realize how difficult work is in outer space, we need to understand what a spacesuit is. It weighs 280 pounds, which is as much as a scooter. You won't feel its weight in zero gravity, but it will still make you sweat. Astronaut Chris Hadfield had described it by saying that every movement inside your spacesuit meets resistance. The suit scratches your skin, squeezes your bones and joints, and forces you to spend twice as much energy on simple movements. In such conditions, you start sweating and your eyes get wet. This moisture flies inside the helmet and blinds you until it evaporates. But if there's too much moisture, it can threaten the life of an astronaut. Such a case happened in 2013 with astronaut Luca Parmitano. He went into space to measure something outside the station. At one point, he felt that the back of his head was wet. He informed the others about it and got an order to return to the station. When Luca was coming back, he had to turn upside down. As soon as he did this, water gushed into his helmet. It covered most of his face. Luca couldn't see or hear. He tried to report the trouble to base, but the water covered his mouth. Fortunately, his partners rescued him and helped him return to the station. When they opened the helmet, almost half a gallon of water poured out. Astronauts' cables are some of the most reliable defenses against floating away into space. But what if one broke from a strong push, or because the astronaut didn't fix it well? For additional protection, there's a backpack called Safer, Simplified Aid for EVA Rescue. It's like a jetpack. It releases gas from small tubes and changes the direction of your flight. If you're spinning in space, Safer stops and aligns your movements. You can take manual control and fly using a special joystick. Safer was first used in 1994, but before engineers created it, there was the MMU, the Manned Maneuvering Unit. In 1984, astronaut Bruce McCandless used it for the first time. You may have seen this famous photo where he floats in outer space without a cable. The problem was that Bruce was the first tester of such a jetpack. He wasn't 100% sure if it would work. He went into outer space and unhooked the cable from himself. There was nothing else to keep him from flying into the infinite black abyss, and his team wouldn't be able to save him. Imagine how scary it must have been. Fortunately, the jetpack worked. However, after 3 missions, NASA decided to stop using the MMU as it was unsafe. After that, engineers invented Safer. Jetpacks and cables are reliable safety systems, but the best protection for an astronaut in space is their skills. Each astronaut has 6 years of higher education and several more years of training. They spend many hours training in virtual reality with spacewalk simulations. They train their body, endurance, and mind, since the main thing in a dangerous situation in space is not to panic and stay calm.
Earth's magnetic field hides a fascinating story. It turns out that it's getting weaker day by day. In fact, it's been doing so for the last 3,000 years. And if this trend continues, we could be in for some trouble within a millennium. What's the big deal? Well, picture this. Magnetic north becomes south, and vice versa. Pretty wild, right? When this happens, our planet's protective magnetic shield might weaken, allowing more cosmic rays to hit us. These high-energy particles from the universe can cause electronic malfunctions in our satellites and produce elements that could be harmful to us. The last time a polarity reversal occurred was between 772,000 and 774,000 years ago. Thankfully, humanity has some pretty smart people on the case who are investigating the history of Earth's magnetic field. They take cores of sediments from the seafloor and study the magnetization of fossils to figure out when these reversals occurred in the past and when they might happen again. Another group of researchers is studying the South Atlantic Anomaly, SAA, a vast region of Earth's magnetic field that is about 3 times weaker than the field at the poles. Using data from multiple satellites, they are trying to figure out what's causing the SAA and how it might change in the future. This could give us a glimpse into how a weakened magnetic field can affect our satellites and our planet. Sure, our generation won't be here to witness these changes, but it does make you wonder what that planet might look like upside down. Magnetically, that is. NASA's astronomers have also announced that in 4 billion years, the Milky Way galaxy is going to get a major glow-up. After a cosmic collision that will shake things up. I'm not talking about a small fender bender here, I'm talking about a titanic collision with our neighboring Andromeda galaxy. Humanity will have to hold on to its space helmet for this one, because the sun might get flung into a new region of the galaxy. However, our Earth and solar system probably won't be seriously affected. Sounds difficult to believe, so how come? NASA's Hubble Space Telescope did some hardcore measurements of Andromeda's motion. Although the galaxies will plow into each other, the stars inside each galaxy are so far apart that they won't collide with other stars during the encounter. However, the stars will be thrown into different orbits around their new galactic centers. According to simulations, our solar system will probably be tossed much farther from the galactic core than it is today. Set your telescopes aside. You don't need to start counting down the years. This event is likely scheduled in about 4 billion years, so chances for us to witness it are 0. Saturn is losing its rings. Thankfully, we won't be here to witness this sad event either. Apparently, the rings are being pulled into Saturn as a dusty rain of ice particles, all under the influence of Saturn's magnetic field. According to NASA's research, the ring rain is draining an amount of water products that could fill an Olympic-sized swimming pool from Saturn's rings every half an hour. The entire ring system will likely be gone in 300 million years. Scientists believe we should consider ourselves lucky to witness Saturn's ring system at all, as it seems to be in the middle of its lifetime. But if you think about it that way, that rings around planets are all temporary, there's a chance we've just missed out on the giant ring system of Jupiter, or those of Uranus and Neptune. These planets have only thin ringlets around them these days. Scientists have long debated whether Saturn was formed together with its rings or if the planet acquired them later in life. The new research favors the second scenario, indicating that they are unlikely to be older than 100 million years, while Saturn itself is around 4.5 billion years old. What caused the rings to appear in the first place? Well, there are a few theories. One of them suggests the rings could have formed when small, icy moons in orbit around Saturn collided. Perhaps their own orbits were messed up by a gravitational tug from a passing asteroid or comet. Who knows what humans might end up looking like in the future? It's unlikely we'll see any major changes in our lifetime. But let's take a journey to the future and ponder what we might evolve into. Will we become cyborgs with all sorts of cool machine implants? Or maybe we'll become a hybrid species of biological and artificial beings? To understand our future evolution, we gotta take a peek at our past. 1 million years ago, Homo sapiens didn't even exist. There were a few other similar species though, like the Neanderthal. Fast forward to today, and humans have become taller and sturdier. Maybe in the future we'll become smaller to conserve energy, as it's predicted that our planet will get more crowded. Speaking of crowded planets, living in these new conditions means we have to adapt, and fast. We're constantly interacting with lots of people, and remembering names is becoming a crucial skill. Luckily, technology might help us out with brain implants that will improve our memory. In the future, we might also have more noticeable technologies as part of our appearance. Imagine having an artificial eye with a camera that can read different frequencies of light. While predicting 1 million years into the future is pure speculation, we can use bioinformatics to make some predictions about the immediate future. Demographic trends suggest that urban areas will become more genetically diverse, while rural areas will become less diverse. And what about space? If we end up colonizing Mars, our bodies could change due to lower gravity. Maybe we'll have longer arms and legs, or even insulating body hair like our Neanderthal cousins. In the future, our moon is also going to witness some dramatic changes. We'll miss these ones too. In about 5 billion years, things are going to get really interesting in this corner of the universe. For now, the sun is chilling in its main sequence phase, just burning hydrogen like nobody's business. In the future, during the red giant phase, the sun is gonna puff up like a balloon until its atmosphere reaches out and engulfs our beloved Earth and Moon. Our natural satellite, which is already moving away from Earth, is gonna get warped around the sun's influence. Its orbit will get all wonky, and it'll end up closer to Earth during the new moon phase than during the full moon. And that's not even the worst part. If left alone, the moon would keep on moving away from Earth until it'll need almost 50 days to orbit us. As the sun continues with its own journey, its atmosphere will drag on the moon and cause its orbit to decay. Eventually, the moon will get torn apart into a stunning ring of debris circling Earth. We're talking about all its mountains, craters, and even the footprints and flags we left there, all scattered throughout the debris field. There's a chance the sun will shed enough mass to spare Earth and the moon from total annihilation. Or if we're really lucky, the sun will lose 20% of its mass and we'll be safe and sound. It's all just theory right now. We haven't seen a red giant star during this phase. The universe itself might go completely dark one day too. Scientists can't predict it with absolute certainty, but they can make some educated guesses. Right now, our universe is 13.77 billion years old, and it's still churning out new stars left and right. It's said that eventually, after about 1 trillion years, the last star will be born. That final star will be a little guy, a red dwarf, just a fraction the size of our sun. These stars are champs at living long lives, slowly sipping on hydrogen to keep their fusion reactions going. But even they can't last forever. Fast forward about 100 trillion years, and the last light will go out. The universe will be dark and lonely, but thankfully, we won't be here to watch it all fade away. Ladies and gentlemen, this is your captain speaking. We'll be ready to take off in 3, 2, 1. Living on a spaceship sounds like a sci-fi movie topic, but gradually turns into a plan for the distant future dream. Let's imagine how it would be. Without further ado, I'll start with the light. On Earth, thanks to the atmosphere, the sky scatters the sunlight, so we get light in different directions. Then there are shadows, contrast, and ambient light. In a spaceship, however, there's no sky to create that cool ambient light. When you're in a spacecraft inside a solar system, one side of the ship can be lightened by the sun or another star, and one side can stay in the shadow. You can think of it as the crescent moon. If your spacecraft manages to go far away from any solar system, you might say goodbye to the bright side of the ship. You would be very far from all stars, so the ship is going to fly in the deep darkness. Don't worry though, the advanced technology will probably find a way to imitate the sunlight. Maybe designers will place LED light panels similar to windows, and inhabitants of the ship wouldn't notice the difference. What about people? A study revealed that a crew of 160 people could create a viable population for 200 years. Here, the important thing is to select the crew members from a large gene pool. No two passengers should be closer than 6th or 7th degree cousins. This is a projection from our day. Who knows, maybe hundreds of years later, whole countries will live in a spaceship. Your neighbor country in the world will be your neighbor in space. This reminds me of the scene from Thor Ragnarok, when the Asgardians who survived Hela escaped with the Grandmaster's ship. They went to Earth to settle down. Maybe we would go to Proxima Centauri b. It's an exoplanet, which is the term used to define planets beyond our solar system. Proxima b is in another star system, and some scientists do believe it has the potential. Some of them believe that there's a possibility that liquid water exists on the surface of a planet. It's important because this planet is our nearest neighboring exoplanet. Yeah, the nearest one, but it's almost 25 trillion miles away. To better understand this proximity, I'll give you a comparison. Currently, one of the fastest spaceships, called New Horizons, goes a whopping speed of more than 30,000 miles per hour. But even with this speed, it would take thousands of years to get to Proxima b. Let's hope we figure out how to warp the space-time equation by then. If I'm realistic, the first option is more likely. Let's assume we made a trip with our fastest spaceships. This would still be a couple of 100-year journey. This leads to another minor problem: the lifespan of humans. The same crew cannot make it to the end of the ride. Here, generation ships shine as a solution. A community of adults enter the ship, then their children and their children. You know, until humanity finally reaches the new planet. There are two other alternatives. If researchers somehow made a way to make people live for centuries, we wouldn't need generation ships. Similarly, there could be a system to freeze people. It'll take 20,000 people to start a healthy population on a new planet. For now, I want to stick with the first scenario. Here's how it would be to live in a generation spacecraft. Dating wouldn't be as romantic as it is on Earth. There's probably a geneticist who will regulate reproduction. Freedom of choice in general would be decreased. The rules will be strict. In every generation, there should be certain tasks to manage. Someone should be a doctor, and someone else should be a plumber. New generations may go under a career planning test. Everyone would be assigned occupations based on their merits, aptitude, passions, and available jobs. It reminds me of Snowpiercer, but hopefully things would go humanely and better in this version. People all need water, and they'll create waste. By then, maybe we wouldn't rely on plastic. Plus, recycling may be on another level. Still, we will need water. A healthy human needs almost 300 gallons of water per year. It's not like they'll stop by on a planet and refill the water reserves. So how can spaceship residents solve this problem? There are already systems to recycle some astronauts' waste into pure water. The next issue is infirmary. A spaceship might have almost no bacteria or microbes. People need them for a stronger immune system. If they get too isolated and land on a planet, they may have difficulty coping with the potential conditions there. Shielding carries importance too. Deep space is a radioactive place. Our planet has a magnetic field that protects us from DNA-frying waves. Out in the open, the spaceship will need a strong shield. Maybe we'll be able to create some sort of force field. NASA is working on systems to grow plants in space. We will probably see special sections dedicated to farming and livestock. I also feel like this type of ship would also carry flora and fauna samples too. Who knows, maybe there'll be specific parks and different mini ecosystems. This would be great for the sanity of people on the ship. I mean, it's great to maintain the existence of the human race, but, existential crises can mess with the passengers. They can eat their space sandwiches in the park and relax a bit with the sound of tweeting birds. Not just a garden, the young passengers might need a playground and school. Well, in this case, cabins, to get an education. They'll probably have a whole new curriculum, How to Stay Alive on a Foreign Planet 101. By the time we have this ship AI, and high-tech robots will probably be more popular than ever, there might be self-propagating robots. We can send these robots to our potentially new planet first and see how it turns out. We can even send robot teams to multiple worlds and see which one has a better habitat. I admit, generation ships look like an idea derived from Hollywood blockbusters, but there's an initiative called the 100-Year Starship Project. Mark G. Millis, the founder of the Tau Zero Foundation, is one of the participants involved in this project. They designed a probe named the Icarus. It has the theoretical capability to accelerate to 1/10 or 1/5 the speed of light. Although the current design of Icarus is not particularly sleek, resembling a skyscraper-sized behemoth composed mainly of rows and clusters of spherical fuel tanks. Millis explains that it's not a definitive representation of what an interstellar craft may look like, but rather the design that makes the most sense to build initially. When it comes to designing starships for humans, gravity is a key consideration in preventing the erosion of bone and muscle density. The solution is to create gravity with a rotating cabin or centrifuge, but it must be large enough to consistently simulate Earth's gravity to avoid disorientation and other health issues. Is there an arrival plan? Assuming that we land to Europa or Proxima b, the crew and the passengers need to be prepared for different scenarios. There should be equipment to scan the territory, or even self-defense gadgets to protect themselves from potentially hostile life forms. Once they successfully arrive, they need tools to build their homes too. When they finally arrive at their new planet, they might start advanced technology to travel around other planets. Hi Mom, I brought you a rock as a gift from the surface of Mars. There could be new occupations and a live space travel guide, and we might need some type of document like a visa to enter other habitable planets. There's a meteorite rain expected, so stay at your base for the next 2 years, says the newscaster. Okay, I'll calm down here. So how would you picture a vessel capable of ferrying humans from one solar system to another? Would it have some sort of wings, or would it look like a rocket? Tell me more about the design in your mind.
Well, your childhood dream is coming true. You've been selected as one of the volunteers to go to space as a tourist. It's time to pack your bags. Must check the airline? Strike that out. Make it spaceship luggage restrictions. And trust me, the low-coaster airline rules down on Earth are nothing compared to the do's and don'ts for the International Space Station. A regular mission to the ISS lasts 6 months, so any ship going up there brings supplies for the astronauts already there. And it's not just some vital materials to keep the mission running, but also crew care packages. Those are meant to make life among the stars more comfortable and include something nice from the crew members' homes or the support staff. There's a weight limit of around 11 pounds, and the size of the package is 9 by 16 inches. Food can be inside, but anything that can produce crumbs isn't welcome. Perfumes, aftershaves, mouthwash, and anything in pressurized cans like shaving cream aren't allowed. And in case you were wondering, video games can't be in your crew care package. There could be some problems with batteries up there. So no video games for months? I might reconsider my astronaut career. Clothes are good to go, but only if they're 100% cotton. One more thing that takes off with the spaceship is an official flight kit. It has around 120 pounds of flags, patches, stickers, and other merch. And no, it's not for sale in case we do find life on Mars. These items from NASA, commercial partners, and international organizations are supposed to come back to Earth to be used as souvenirs, museum exhibits, or awards. And, of course, you'd have to send NASA an official request, and they'll decide which items and how many can go. Now, life in space would be sad if you can't bring something that reminds you of home, right? Well, NASA's got you covered. You can also bring a personal preference kit on your mission. Don't get too excited though, it's just around the size of a lunchbox and can fit a bit over 3 pounds. PPK was introduced during the Gemini program, when 2 people could fit into a capsule instead of 1 like before. Back then, personal items had to go inside a gray nylon bag with a drawstring. Astronaut Wally Schirra chose to pack his bag with 20 gold medals, 5 silver medals, flags, patches, and a Florida hunting license. I wonder what plans he had for his time in space. His colleague, Michael Collins, who went on the first mission to the Moon, brought 3 flags with him, among other things. Years later, he took part in a NASA poll on Twitter and shared that he wished he had brought coffee and a good book to read. The more popular choices for PPK are family photos, ball caps, t-shirts, pins, and other things with logos of universities or teams and other memorabilia that mean something to them but remain a secret. Many crew members also bring musical instruments that later stay on the space station. One astronaut even got an alto saxophone for his birthday in space. That one must have been tough to hide. Another popular carry-on choice is camera gear. The views up there are too good not to capture. So, you finally choose the particular photos of your relatives to take with you and which should stay on Earth. You reach the ISS, embrace its residents, and naturally, your next wish is to take a shower after the trip. But don't get your hopes up. Water doesn't flow in zero gravity, so you won't be able to take a refreshing shower up there. Plus, water is pretty heavy, and it would be pretty expensive to send rockets filled with it into space. So, astronauts use pre-moistened wipes or towels with liquid soap to wipe their hands and faces. Another wet towel can serve to clean the rest of the body. But what about hair? Well, meet your new friend, the rinseless shampoo. You can't let splashes of water escape and mess up the electronics, so you gotta use a straw-like nozzle to run the water through special bags made of foil and plastic. Most of the water used for it goes back into the air conditioning system. It gets filtered and recycled to be used for drinking. Now, astronauts do brush their teeth, but even that simple task requires some skill in space. You'll need to attach the toothpaste tube to a wall and then squeeze a tiny bead of water over the toothbrush. Then you can brush your teeth like you do on Earth, squeeze some more water, and wipe it off with a towel to clean the brush. And oh, there's no sink to spit into, so you'll have to take a couple of sips from your water bag and swallow the toothpaste with it. Boy, sign me up. All that space routine has worn you out. Time to replenish your energy supplies. Luckily, space food is no longer mashed up in a tasteless mix and packed in tubes we've all seen in movies. Space food advanced along with space technologies, and now astronauts have a diet similar to yours down on Earth. They can eat fruits and brownies in their usual form. When someone on the ISS wants to snack on mac and cheese, they just need to add some water to it. There are no fridges up there, so you can't bring your favorite ice cream, and all other foods must be properly stored. It mostly comes in plastic packaging or cans. To prevent your meal from flying away, that packaging comes with Velcro patches and can be attached to a tray or table. There's a convection oven, so those lunches among the stars won't be as cold as outer space. Astronauts get 3 meals a day, and nutritionists make sure they're all well balanced. You can choose between coffee, tea, orange juice, fruit punches, and lemonade when you feel thirsty. Fizzy drinks don't fizz in freefall, so you can't bring soda. There's ketchup, mustard, and mayo to spice up your diet, but the salt and pepper only come in liquid shape. Otherwise, they clog the air vents and other equipment or get stuck in the astronauts' eyes, mouths, and nose. Yep, we already know crumbs aren't welcome in space for the same reason. But what about bread? One option is to replace it with tortillas. Another option is to sneak a sandwich on your spaceship without anyone knowing. John Young tried it once, but the crumbs were a disaster, so he couldn't enjoy his corned beef sandwich at all. You could also wait for the scientists to find a solution. They've been working on it for a while. A German company called Bake in Space teamed up with the German Aerospace Center and a bunch of researchers to create the perfect dough and find a way to bake it right in space. They need a special oven, and its surface shouldn't heat up over a certain temperature. So far, the astronauts have successfully baked cookies on the ISS. It took way longer than it would in a regular kitchen, but the result was worth the wait. The whole station smelled like cookies. Speaking of smells, they can hang on for years in the space station, and you just can't open the window and air the room, you know. So even a non-toxic material can give off odors that could tamper with the astronauts' work or even make them sick and put the mission at risk. That's why NASA has its own chief sniffer, also known as Nostradamus. His work is to smell all objects that will be in the habitable zone of the ISS. Now, you can't wait to journal about everything you've learned. Too bad pencils aren't welcome in space. The lead could easily break off, float away, and cause some major drama. A regular pen wouldn't work in weightlessness, so a special pressurized space pen premiered back in 1968. There are around 80 models of it now, and dozens of them are currently floating on the ISS. It's been one busy day in space so far, and your mission is just getting started.
Astronomers have been asking one question for decades. Is space really as black as we think it is? Well, NASA's New Horizons space mission might have just given us the answer. After exploring Pluto, the spacecraft kept going and is now billions of miles away from Earth. This means it's far from all the light pollution we get from sources like the sun and dust particles around our planet. Scientists used the spacecraft's simple camera to take images of what looked like incredibly boring blank space, free of bright stars or anything else that could scatter light back into the camera. They then processed these images to remove all known sources of visible light. Once they'd removed the light from stars, plus scattered light from the Milky Way, they were left with light coming in from beyond our own galaxy. But here's the surprising part. They found that there was still plenty of unexplained light. In fact, it was about equal to all the light coming in from the known galaxies. That means there's just as much light outside of galaxies as inside them. So, where does all this light come from? Well, it could be coming from sources we haven't yet discovered, like small, faint dwarf galaxies or unknown phenomena out in the universe. Or it could be associated with dark matter, which is still a mystery to scientists. With this groundbreaking research, we can say that space isn't as dark as we know it. What if we take all the light from the stars and galaxies out there and throw in some gas and dust clouds? What color do we get? Beige. This leads us to another question. Do we still need the sun if our space is colorful? And the short answer is, yes, we do. The colors of space are a result of the interactions of light with different celestial objects, such as stars, galaxies, and gas clouds. While these colors are fascinating to observe, they do not provide the energy life on Earth needs to survive. There you go. Don't expect to see the color of the sky in space.
These eerie objects are called quasars. They're some of the brightest and most powerful objects in the universe. They lurk in the depths of space, consuming entire galaxies with their insatiable hunger. But what are quasars? Where did they come from? And most importantly, are they dangerous to us? Picture a supermassive black hole, a cosmic monster so massive that it can swallow entire stars and bend the fabric of time. Usually, there's such a black hole in the center of every galaxy. That includes our own Milky Way galaxy. Ours is named Sagittarius A star. Sounds like the name of a hipster coffee shop, but in reality, it's a terrifying celestial body which is 4 million times heavier than our Sun. You could even see it online. For the first time, we took a photo of this black hole in May 2022. But don't worry. Even though it's supermassive, it's not going to swallow us up anytime soon. This black hole is relatively small, and is too tiny to eat an entire galaxy. So it's more like a cosmic vacuum cleaner that sucks up stars or gas that gets too close. But there are black holes in the centers of galaxies that are way heavier and more dangerous than ours. They can weigh millions or even billions of times more than our own Sun. Now, imagine one of these monsters. Usually they're surrounded by a swirling, glowing disk of gas and dust, like water swirling down a drain. It's called an accretion disk, and it's where the magic of quasars happens. As material from the accretion disk falls toward the center, it heats up to millions of degrees, releasing vast amounts of energy in the form of radiation. And this radiation is what we observe as a quasar. So basically, the more material a black hole can consume from its surroundings, the brighter its quasar will be. This is what makes them so bright and powerful, shining like beacons in the night sky. And just imagine, some black holes can actually make entire galaxies their meal. Now, combine their ravenous appetite with some intense radiation, and you'll get a truly awe-inspiring display of cosmic power. No wonder we can see them, even though they're some of the most distant objects in the universe. Quasars were discovered in the late 1950s by accident. Astronomers were just chilling and looking at the sky when suddenly they stumbled upon something strange. Radio signals that had no visible source. By 1960, hundreds of these strange objects had been found. Astronomers named them quasars, short for quasi-stellar radio source. These objects were small and far away, but their energy output was immense and difficult to explain. Some thought that these were new types of stars. Others even proposed wild things, like quasars being made of antimatter or being the end of a wormhole. But all these theories were discarded. A scientist named Martin Schmidt was the first one to get to the truth. However, many astronomers didn't believe him. Schmidt had to do a lot of extra work and gather lots of evidence to prove his theory. And finally, he prevailed. And that's how we discovered quasars. Don't you love the scientific method? And since then, astronomers have been captivated by these objects. Why? Because they have some pretty eerie qualities. Hey, you could call them quasi-quasars. For example, they kind of defy the laws of physics. They emit jets of particles that travel at speeds close to the speed of light. These particles move so fast that they can even distort the very fabric of space and time. But sometimes, they also help us confirm the laws of physics. Now imagine driving a car. As you drive, objects in the rear window start to appear smaller and smaller until they disappear from view entirely. That's exactly what happens with quasars, except they're moving away from us at incredibly fast speeds, up to 90% the speed of light. Wonder why they're trying so hard to sprint away from us. But in any case, this helps us confirm that the universe does expand for real. Another eerie thing about quasars is that they're incredibly old. Some even date back to the time when galaxies were forming, or to the birth of our universe. Additionally, quasars are some of the most distant objects that we can observe in the universe. Some of them are located billions of light years away from us. This means that when we observe a quasar, we're actually seeing light that was emitted billions of years ago, when the Earth was much younger and different than it is today. And that's why they work like cosmic time capsules. Studying them gives us a glimpse into the distant past. You see, galaxies are like giant cities, with stars and planets serving as the inhabitants. But just like cities evolve over time, galaxies also undergo changes as they age. And that's where quasars come in. They're like the urban planners of the universe. They shape the galaxies through their powerful gravitational influence. By eating galaxies and releasing intense radiation, they can trigger star formation and shape the structure of the galaxy itself. It's like the cosmic equivalent of a master chef, or a leaf blower, you pick. For example, let's take galaxy mergers. Here are two massive entities coming together, swirling and spinning around each other. As they get closer and closer, their gravitational pull becomes stronger, and they start to merge into a new, bigger galaxy. It's a beautiful and dramatic process, one that can take millions of years to complete. But all this doesn't go without consequences. The gas and dust within the galaxies collide, creating massive shockwaves that trigger the birth of new stars and even supermassive black holes. And this is where the quasars come into play. Some quasars may be born during these galactic get-togethers, and thanks to this, they help us study the effects of this process and the evolution of galaxies over time. But it's not all serious science and no fun. For example, how about gravitational lensing? Now, that's something straight out of a sci-fi movie. It happens when the gravity of a massive object, like a quasar, bends the path of light from a more distant object, like a galaxy, behind it. It's like having a really big magnifying glass in space. When you combine a quasar with gravitational lensing, you get some seriously awesome cosmic eye candy. The result is kind of like a funhouse mirror, where objects appear warped and twisted in strange and mesmerizing ways. Gravitational lensing isn't just for show. It's also a powerful tool for astronomers to study the distribution of dark matter and the structure of the universe. And that's not all. Some scientists have proposed that quasars could help us build the map of the universe. They can work like giant neon road signs. Turn left at the quasar and you'll reach your destination. They're like lighthouses that help us navigate through space. By analyzing the light from different quasars, astronomers can determine the distances between them and create a 3D map of the universe. And the best part? Quasars are located throughout the entire universe. That's why this cosmic map can give us a comprehensive view of the universe on a scale that was previously unimaginable. Who knew that a giant galaxy eater could be so useful? There's still a lot we don't know about these mysterious objects. In 2007, a team of astronomers made an astonishing discovery: the first true binary quasar. Basically, this means two huge quasars spiraling around each other. What's more, they were hiding in plain sight. For years, scientists had known about this radio source, but had never realized that it actually comes from one lovely couple. The astronomers also estimated that this pair may have a mass of about 100 billion suns. They're super distant, though, at an astounding 12 billion light-years away from our blue planet. Overall, quasars are a fascinating and complex phenomenon that continues to baffle and intrigue scientists. They may be cosmic galaxy eaters, but they're also playing a critical role in the formation and evolution of the universe. And who knows? Maybe one day they'll become one of the keys to unlocking the mysteries of our universe. Oh, you crazy quasars. So, what comes to your mind when you hear the words green monster? The Hulk? Shrek? Probably. But definitely not a young supernova in the Milky Way galaxy. Oh, and if you have forgotten what our home galaxy looks like, here, have a look. So anyway, is that supernova indeed green and, scary? Not really. But let's start from the very beginning. Cassiopeia A, aka Cass A, is the remnants of a stellar explosion astronomers spotted in the sky 340 years ago. This supernova is 11,000 light-years away from us in the constellation Cassiopeia, and its remains span about 10 light-years. Recently, scientists have managed to capture the sharpest image of these leftovers yet, all thanks to the James Webb Space Telescope, the largest optical telescope in space. The image is full of bright colors, brilliant green, orange, and pink. Maybe if you printed it out, it would make a great painting for your living room. Just like this canvas. Each hue represents a different wavelength of infrared light, which is normally invisible to the human eye. The image can help astronomers figure out what happened to the poor star before its demise. Cass A is the youngest known remnant of a massive star that once exploded in our galaxy. On its exterior, at the top and left, you can see curtains of material that seem red and orange because of the emission of warm dust. That's where the ejected material from the exploded star collides with the surrounding gas and dust. Inside this outer shell, there are chunks of bright pink bubble-shaped material that form clumps and knots. It comes from the star itself. This material is shining because of the mix of heavy elements like neon, argon, and oxygen. Astronomers have spotted some dust emissions in that region too, but they haven't located the sources of these emissions yet. There's also a prominent green loop extending across the right side of the supernova's central cavity. And if you look closely, you'll notice that a big region of Cass A is pockmarked with something that looks like small bubbles, which makes the thing even more complex and hard to understand. The first X-rays from Cass A appeared in the 60s, but light from the supernova probably reached Earth in the 1600s. Unfortunately, there are no confirmed written observations of the supernova from those times. It must have looked like an extremely bright star, and historians still doubt whether any observers noticed it. Oh, and I bet you've been wondering about the nickname, right? This space phenomenon was called the Green Monster in honor of Fenway Park in Boston. Its large green left-field wall has the same name. One of the main questions CAS-A might help us answer is, where does all that cosmic dust come from? Astronomers have discovered that even very young galaxies at the early stages of their lives are filled with massive amounts of dust. So, does the universe need vacuum cleaning, or is the problem more complicated? One of the crucial components in the appearance of this dust seems to be supernova. They spew truly terrifying amounts of heavy elements, which are basically building blocks of dust across the cosmos. So let's try to figure out what these supernovae are and how they occur. Good old stars keep their spherical shape because their gigantic mass creates a powerful gravitational field that pulls gas toward the center, and at the same time, their cores produce enough energy to prevent gas from gathering too close to the center. All this creates a nice balance and a beautiful ball-like shape. But once a star becomes too old and massive, about 4 to 8 times as big as our Sun, it doesn't have any more fuel left. That's why all the reactions in its core stop. The star's outer layers instantly try to collapse inward, but they bounce off the core, which remains incredibly dense. That's when everything but the star's core blasts out all over the universe in a bright supernova explosion. Now, as you may know, our solar system itself can be a pretty scorching place. For example, the temperature of Earth's core almost reaches a whopping 10,800 degrees Fahrenheit, which is about as hot as the temperature on the surface of the Sun. As for the Sun's super-hot center, it's heated up to 27 million degrees Fahrenheit. Okay, that's hot. But if we talk about the universe, such temperatures are nowhere near hot in comparison with a supernova. As you now know, it's the very last stage of a star's life, which ends in a gigantic explosion. This explosion is one of the largest in space, and it unleashes enormous amounts of energy. Therefore, the temperature at the core of a supernova is an incredible 6,000 times higher than that of the Sun's core. And it means it can reach several billion degrees Fahrenheit within microseconds, which is almost impossible to imagine. After that, atoms get crammed together so infinitely closely that the squeezed core recoils and a star explodes, creating a superheated shockwave. Anyway, let's get back to our CAS-A. By studying it with the help of the James Webb Telescope, astronomers hope to get a better understanding of its dust content. This, in turn, will help them figure out where the building blocks of stars, planets, satellites, and us humans come from. Experts can locate regions with different gas composition and look at the types of dust that form there. Oh, by the way, if you're interested in space too, but don't have your access to the James Webb Telescope, you can get yourself a telescope of your own and enjoy amazing views. Supernovae, as the one which created CAS-A, are very important for life as we know it. They spread such elements as, for example, calcium that we have in our bones, or iron our blood contains, literally seeding new stars and planets. You, my friend, are made from star stuff. Supernovae don't always mean the end of stars. Even though a star loses its outer layer, it might still survive the explosion. Then it either becomes a black hole or a new kind of star. See for yourself. Even without the outer layers, a star's core keeps collapsing. At one moment, the pressure inside becomes so high that electrons and protons virtually melt into each other and form neutrons. The result of this crazy fusion is a neutron star, whose mass consists of 90% of neutrons. It means that the thing just can't get squashed any tighter. Then, energy starts to leave the fading star, transforming it into a neutron star. And the amount of this energy is so great that it can be compared with the combined light emitted by all the stars in the observable universe. Energy is leaving the star in the form of neutrinos, subatomic particles that are similar to electrons but with no electric charge and a very small mass. And during a supernova explosion, the star emits almost 10 times more neutrinos than the number of protons, electrons, and neutrons in the Sun. No wonder that in such conditions, something truly scary gets born. A neutron star, which is basically a monster nucleus, the central part of an atom, is relatively small. Even though scientists don't know for sure how big neutron stars are, they suppose that these space bodies shouldn't be bigger than 12 miles across. For comparison, our Sun is almost 865,000 miles across, which is 109 Earths put side to side. But even with such a modest size, any neutron star will be at least 1.5 times heavier than the Sun. Think about this. If you scoop just a teaspoon of neutron star insides, this stuff would weigh no less than 1 billion tons. That's very dense. So dense that the next stop is the black hole itself. Well, what can I say? Space is an endless source of mystery and inspiration for me. I'm even considering adding some space vibes to my home, and I know just the thing to do it. Hey, don't thank me.
Scientists were looking at a list of gas clouds when they saw something strange. 5 groups of blue stars that are not quite a galaxy and not a known type of star cluster either. These groups of stars are called blue blobs, and they're located in the Virgo galaxy cluster. Now, the big question is, how did these blue blobs form if they don't have any nearby parent galaxy where they could form? Scientists realize there are some heavy metals present in these blobs. Generally, when stars are born, they create heavy elements called metals. These metals are essential building blocks for new stars. In big galaxies, many stars form over time, and as a result, more metals get created too. These heavy metals in the blue blobs were a clue that the stars in these blobs were formed from gas that was stripped from a larger galaxy. Think of it as a piñata. The candy is the gas, and the piñata is this bigger galaxy. The blue blobs are the leftover candy that was scattered around. Wow, didn't expect to get hungry while talking about stars. How did the gas get stripped away from the bigger galaxy anyway? There are 2 ways. When galaxies pass by each other, their gravitational attraction can cause gas to be pulled away from one galaxy and into the other. This is called tidal stripping, and it's the first way these blobs can happen. It's like when 2 magnets attract and pull metal objects toward each other. Another way is ram pressure. This happens when a galaxy moves through a cluster of hot gas at a pretty high speed. The gas in the cluster can push against the gas in the galaxy and force it out back, similar to a car pushing air out of the way as it drives, and you lose your hat in a strong wind. As time goes by, these stars and the blue blobs will keep on moving apart. Eventually, they will form smaller clusters. Have you ever seen pictures of Earth taken from space? They're amazing. But have you seen the one with 2 blue blobs of light? The first blob of light you see here is a large lightning strike in the Gulf of Thailand. It's rare to see lightning from space because of all the clouds, but this one was so huge it lit up the clouds around it like some kind of a brilliant ring. How cool is that? The second blue blob of light is a bit different. We're looking at the reflection of the moon's light on our home planet. The moon actually reflects the light coming from the sun onto the Earth. And when that light goes through the Earth's atmosphere, it creates a big blue blob with a fuzzy outline. It's like a shiny blue hat our planet is wearing. It's similar to the reason why the sky is blue during the day. When sunlight enters Earth's atmosphere, gases and particles in the air scatter it in all directions. Blue light has the shortest and smallest waves, so it gets scattered the most. And that's why we get to enjoy a beautiful view of a clear blue sky. The same thing actually happens to the light coming from the moon. When it reflects off the Earth and goes through the atmosphere, the blue light waves get scattered the most, making the moon appear blue in the photo. Speaking of unusual stars, there's one in the Centaurus constellation called Lucy. It looks like a tiny white dwarf, but it's actually very dense. There's a mass of the entire sun squeezed into an object only 1/3 of the size of our home planet. That's like stuffing a whole watermelon into a golf ball. Lucy is also incredibly cool. Its core temperature is almost 12,000 degrees Fahrenheit. This may sound hot at first, but for comparison, our sun is about 27 million degrees Fahrenheit. And the best part that makes Lucy so special is the diamond at its heart. Its carbon core has crystallized into a massive diamond that's 10 billion trillion carats in size. It's hard to even imagine how big it is. Scientists found out about this awesome diamond by listening to the star's vibrations, which is like a star's heartbeat. And after they discovered Lucy, scientists found some other stars with crystallized cores and massive diamonds the size of Earth, too. Our universe is like a giant jewelry store. Most of the astronomers from the northern hemisphere are familiar with the star named Vega. First, it's brighter than expected. But if you could take a look at it from a different angle, you'd see this star is actually squashed. It has a specific oblong shape because it rotates at a high rate. It spins once every 12.5 hours, which throws the material out around its equator. This material then cools and darkens, and forms a dark, mysterious halo around Vega. When stars reach the end of their lives, they often explode in a dazzling supernova, getting brighter and brighter before they finally fade away. But one supernova, IPF-14Ls, decided not to obey the rules. It started to fade away like most other stars, but then, when everyone expected it to be gone, it suddenly came back to life and brightened up again. And not just once. It kept fading and brightening at least 5 times in a row. Scientists were so surprised to see this. When they measured the light from the supernova, they found it was evolving 10 times slower than other stars. It was aging way more slowly, too. When it looked 60 days old, it was actually 600 days old. It could be even older, because scientists had recorded another supernova in the same spot almost 70 years ago. There are some theories as to how it could have happened. Maybe the supernova was bumping into some surrounding material and then making it glow. Or maybe it was a giant star that was shedding material all the time to prevent, or at least postpone, its own collapse. At first, it may seem like you're looking at a simple variable star here, My Camelopardalis. But when astronomers looked more closely, they realized it was a pair of stars. The two stars are moving around each other at really high speeds, and their atmospheres are starting to mix because they are so close. People believe this example is the start of a union between two stars. In the end, the two celestial bodies, which already weigh 32 and 38 solar masses each, will join together to make a gigantic one with more than 60 solar masses. Scientists have thought for a long time that this is how super big stars form. They've never really seen it happen. The universe is 13.8 billion years old, and from what we can see, one mysterious star, HD 1140283, could be 14.4 billion years old. Something's not right here. This star has all the chemical signs of a second-generation star, which is a star that formed from gas and dust after the first generation of stars exploded. This star, sometimes called Methuselah's star, is 190 light-years away. Its brightness, distance, and composition help us figure out how old it is, at least 13.2 billion years old. While the age of 14.4 billion years is probably put there as a potential range. Even if it's younger than the universe, or is it? It's still by far the oldest star near us. Let's not forget the one with a tail either. It's called Mira. Sometimes it's bright, and other times it's faint, making it a bit of a tricky one to spot in its constellation. Sometimes it's one of the brightest stars up there, while other times it is one of the fainter ones in its constellation. It's the system with two stars, a red giant and a white dwarf. The red giant used to be like our own sun, but now, as it's closer to its end, it's shedding its outer layers into space. And Mira has a comet-like tail too. As the red giant sheds its outer layers, it creates a stream of gas and dust that follows the stars as they move through space.
Ah, space, the final frontier. It's a vast and mysterious expanse that has fascinated us for centuries. But as much as we've learned about it, there are still plenty of things that we've been lied to about when it comes to space. Let's take a look at some of the biggest lies we've been told about this topic. First off, we have the idea that space is just this pristine, untouched wilderness. But that's not exactly true. We've been littering space with our debris for decades. Everything from old satellites to rocket parts. In fact, there are over 20,000 pieces of debris orbiting Earth right now, and they're causing all sorts of problems for future space missions. So if you're planning on visiting space anytime soon, watch where you go. You never know what kind of garbage might be floating around. Did you know that the sun is not actually yellow? It's green. Well, kind of. You see, scientists measure the temperature of a star by the color spectrum it emits. Cooler stars appear red, while the hottest of stars look blue. Our sun emits most of its energy at a wavelength that's close to green. But because it emits other wavelengths too, all these colors mix together, and your eyes see this vibrant mixture as white. From Earth, however, the sun looks yellow because our atmosphere is really good at scattering blue light. If our star was actually yellow, Earth would become a frozen rock, and we'd all be polar bears. Plus, the sun isn't on fire for real. It's a big ball of gas, mostly made of hydrogen and helium, and it works more like a gigantic nuclear reactor, constantly fusing hydrogen atoms to create helium inside its core. This process releases enormous amounts of energy. That's why the sun is so hot. Oh, and speaking of setting things on fire, explosions in space aren't real. Sorry, Star Wars fans, a spaceship can't go down in a violent blast because there is no air out there in space. No air means no oxygen, and no oxygen means no fire. Now, you might also think that there are too many stars in the night sky for you to count, but in fact, you can do that. According to the Yale Bright Star Catalog, there are 9,110 stars that you can see from Earth with the unaided eye. So, technically, you can count them, but I wouldn't be surprised if you lost count. And if you're worried about flying through an asteroid belt, don't be. Although it does have trillions of space rocks that range in size from space dust to a quarter of the size of the Moon, they're very spread out. The asteroid belt between Mars and Jupiter is 140 million miles across, which is 1.5 times the distance between Earth and the Sun. This spreads space rocks thousands of miles apart, making it almost impossible for a spacecraft to collide with one. You'll instantly freeze in space without a suit. Nope, you won't turn into a popsicle right away. It's gonna take a bit longer than that because heat and cold don't really move very quickly in the vacuum of space. But unfortunately for you, there's a bigger problem at hand. You won't be able to breathe. After just 15 seconds, your brain won't be getting enough oxygen from your blood, and you'll pass out. And then after just 2 minutes, it's curtains for the rest of your organs. So, in short, if you find yourself playing astronaut without a spacesuit, it's game over pretty quickly. Did you know that space doesn't have any temperature at all? That's because the temperature is defined by the speed at which particles move and the amount of energy they have. In the true vacuum of space, there are no particles to move around, making it temperatureless. Of course, some parts of space are really hot, like areas around stars. But the further away you get from stars, the more spread out particles are, making those areas of space pretty chilly. Number 9 is our planet's shape. No, it's not flat, but it's not a perfect sphere either. Yeah, it bulges at the equator because of our planet's wild spin. It's like Earth is doing its own little dance. And because of this bulging, launching spaceships from the equator is much easier than from the poles. Now, when it comes to sound in space, it's a bit of a tricky situation. You might think that no one can hear you scream, but that's not entirely accurate. The thing is, sound needs something to travel through, like air or water. In space, things are super spread out, so all those epic space battles and galactic explosions would be completely silent. Yet there are some places in space with enough particles for sound to travel through. For example, you can hear the black hole at the center of the Perseus galaxy cluster. Another myth is about zero gravity. That's not a thing. There's still some gravity hanging around the International Space Station, about 90% of what we feel on good old Earth. But astronauts get to float around because they're basically free-falling around the planet. And let's be real, Hollywood's version of space travel is not factual. Sure, orbits are a thing, but different altitudes mean different speeds, so moving from one orbit to another isn't exactly a walk in the park. You can't just push yourself in the right direction and hope for the best. You gotta take those orbital velocities into account. This reminded me of the 2013 movie Gravity and how Sandra Bullock tried to survive in space. Hollywood sure added some fuel to these myths. Yet again, who can blame them? Back in 1976, NASA's Viking 1 spacecraft snapped a photo of a curious rock formation on Mars that looked suspiciously like a face. Some folks out there claimed that it must have been proof of extraterrestrial life on the red planet, but NASA had a different take. According to the space agency, the face was nothing more than a bunch of rocks piled up in such a way that the shadows they cast created an illusion of facial features. It turns out it was just a regular hill that got a little too much credit for being photogenic. The solar system stays in place. Lie! It's zooming through space at a speed of 140 miles per second, which means that it's whizzing through the cosmos faster than a cheetah chasing its prey. It takes us 230 million years for the solar system to complete a full orbit around the Milky Way. It's a good thing it isn't getting a speeding ticket, because that would be one astronomical fine. Eh? Without the sun, planets would be pretty chilly. We're talking about temperatures as low as -455 degrees Fahrenheit. Brr. But with the sun around, the planets get to enjoy much more livable temperatures. Of course, not all planets are created equal. Mercury, for example, is the closest to the sun. Venus, on the other hand, is farther away, but somehow manages to be even hotter than Mercury. The distance from the sun isn't the only factor that affects a planet's temperature. Other things like the planet's size and reflectivity also come into play. So Mercury being the hottest planet in our solar system is a false proposition. No, just because it's the closest one to the sun doesn't mean it's the hottest. Even though we've been deceived in some ways, that doesn't make space any less amazing. It's still a vast, beautiful, and utterly fascinating part of our universe. And there's still so much we have yet to discover. Who knows, maybe one day we'll really discover little green people out there. Or maybe we'll find out something even more incredible. Until then, we'll just have to keep dreaming and exploring. There, you got 14 things on our list. Do you have any other space myths to debunk?
Hey, look at this blazing monster. It's a white dwarf. These stars are known for gobbling up passing objects, and one day, these objects might be the planets of our own solar system. According to a new study, parts of the solar system will be pulled into a white dwarf star, crushed up, and eventually ground into a fine dust like coffee beans in a blade grinder. Hey, you like that analogy? Now, white dwarfs are a final stage of a star's life. It's a small but very dense star that's typically the size of a planet, the result of a low-mass star exhausting all the nuclear fuel in its center and losing its outer layers as a planetary nebula. When our sun turns into a white dwarf, and it is bound to happen sometime, it'll destroy the asteroids and moons around Mars and Jupiter. They will be pulverized by its gravity. Earth, though, will be swallowed up even before the sun turns into a white dwarf. But it won't happen for another 6 billion years. Researchers working on this topic have come to such conclusions by observing what happened to space bodies, asteroids, moons, and planets that were passing close to 3 white dwarfs. For 17 years, they observed and analyzed transits. That's when the brightness of a white dwarf dips because of an object in a stable orbit passing in front of it. In the case of white dwarfs, we can predict such transits and use them to study the stars themselves and celestial objects passing by them. So, when something gets too close to a white dwarf star, the star's immense gravity rips it into smaller and smaller pieces of debris. The team also found out that transits of such debris are chaotic. Plus, this debris is oddly shaped, which means that it is being devoured further. The first white dwarf used for studying the transit process, this here guy, seems steady and well-behaved over the last few years. Well, until scientists found some evidence of a massive catastrophic event that occurred in 2010 or so. The next star dims irregularly every couple of months before brightening again. And the third dwarf star used to behave close to theoretical predictions. It had transits that varied in number, shapes, and depths. But the latest study has shown that the transits are now completely gone. And this indicates the unpredicted nature of transits. One minute you see them, the next, poof. The reason might be the chaotic environment they have to exist in. As for our own solar system and our planet in general, its fate looks pretty sad. Earth will be swallowed by the expanding sun even before our star turns into a white dwarf. As for the rest of the solar system, located further from the sun, some of the asteroids between Mars and Jupiter, as well as some of Jupiter's moons, will be destroyed later. Oh well, they're likely to get dislodged and travel too close to the white dwarf. Now, at the same time, astronomers aren't 100% sure that it's exactly what will happen with our solar system. So I guess we'll just have to wait and see, for like 6 billion years. Speaking of white dwarfs, scientists have recently found one that has a bizarre metallic scar on its surface. This blemish could have formed after the star ripped up and ate a tiny planet orbiting it. White dwarfs with traces of metal in their atmospheres aren't rare. These traces are left by planets falling into stars, affected by their gravity. Experts have long thought that such metal should be distributed evenly across the surface of such polluted white dwarfs. But a new study has discovered a white dwarf with a weird concentrated patch of metal. This star was monitored over a period of 2 months with the help of the Very Large Telescope in Chile. The researchers found an opaque patch of metal. It was located over one of the star's magnetic poles and blocked some of the star's light as it rotated. Based on this position, astronomers concluded that the material could have been funneled into the star by its powerful magnetic field. This process is similar to one causing auroras on Earth, where charged particles follow the magnetic field to the surface. Now, the planet destroyed by the white dwarf was most likely very small, around the same size as asteroid Vesta in our solar system, which is a mere 326 miles across. Its debris is now prominently displayed on the host star's surface. It makes it easier for researchers to examine what the planet's geochemistry was before it was devoured. Such a study might even turn out to be one of the best ways to observe small worlds beyond the solar system, even if such a world has already met its demise. There might be many more scarred stars like this one. The one in question was the first, but probably not the last. Even better, astronomers have already discovered 2 white dwarfs that seem to have similar scars. Making repeat observations of such stars might help us unearth, pardon the pun, no, I meant to do that, unearth even more secrets and make more discoveries. Another bizarre white dwarf discovered not long ago seems to have stopped cooling due to the formation of internal crystals. It challenges existing theories on star aging and also questions the method of stellar age estimation. But scientists might have understood why it may be happening. White dwarfs are believed to be dead stars. They keep cooling down over time, and normally this process can't be reversed or paused. But in 2019, the European Space Agency's Gaia satellite discovered a number of white dwarf stars that had stopped cooling for more than 8 billion years. It might mean that some white dwarfs can generate a lot of extra energy, which is at odds with the classical dead star theory. At first, astronomers couldn't figure out how it might happen. But in the end, more than 97% of stars in the Milky Way galaxy turn into white dwarfs. Astronomers have long thought that such stars are at the end of their lives. After depleting their nuclear energy source, they stop producing heat and cool down. Eventually, the dense plasma in their insides freezes into a solid state and the star solidifies from inside out. The whole process can take billions of years. But the new research claims that in some white dwarfs, this dense plasma doesn't simply freeze. Instead, its solid crystals forming upon freezing become less dense than the liquid and start floating around. They displace the heavier liquid downward. The movement of heavier material toward the center of a white dwarf releases gravitational energy, and this energy is enough to interrupt the star's cooling process and halt it for billions of years. Now, this explanation actually matches all of the properties of the unusual white dwarf population. But this is the first time such a transport mechanism has been seen in any type of star. And that's incredibly exciting. A totally new astrophysical phenomenon. But why does it happen in some stars but not in others? It most likely depends on the composition of the star. You see, some white dwarf stars are formed by the merger of two different stars. When they collide and form a white dwarf, it changes the composition of the star, which allows the formation of floating crystals. So this discovery might mean that astronomers will have to review the ways they use to determine the age of stars. At the moment, white dwarfs are often used as age indicators. The cooler a white dwarf is, the older it's believed to be. But now, we already know about possible delays in the cooling process of some dwarfs. It makes the popular age determination method more unreliable. Some stars of a given temperature may be billions of years older than we previously thought. The recently uncovered transport mechanism within white dwarfs means that some of these stars can be shining as bright as normal for billions of years. This complicates age dating and the use of white dwarfs to reconstruct the formation of our galaxy. Hey, stay tuned.
An asteroid broke off the moon and now it's super close to Earth. Does it pose a danger to us? Oumuamua, also known as 2016 HO3, spins super quickly as it orbits near our planet. Let's call it HO3 for short. Astronomers found it on April 27, 2016. Compared to other asteroids, it's tiny. On Earth, though, it would be the size of a small building, or about half the size of the London Eye Ferris wheel. They discovered it in Hawaii, and its name roughly translates to a fragment of something that seems to wobble. After some study, they realized that this asteroid might be a chunk of the moon that got blasted into space. There's a part of the moon called Giordano Bruno crater, named after an Italian philosopher, that guy who had to pay quite the price for his ideas. If you look at it from space, Giordano Bruno stands out because it's surrounded by some rays of material. They're super huge, stretching over 93 miles and are still bright. This means that an enormous boom once happened there. There's an interesting story about this. In 1178, 5 monks were traveling in Canterbury, England. Suddenly, they saw something strange happening on the moon. They said it looked like the moon was splitting, with flames and sparks. Then there was a darkening that spread all across the lunar surface. In the 20th century, scientists found these records and thought that these monks saw the formation of the Giordano Bruno crater. But later it turned out that the crater is about 4 million years old. And thank the stars, because such a massive impact, if it really happened in the 12th century, would have gone crazy on our planet. It would have caused a huge meteor storm on Earth. In any case, our HO3 is most likely a piece of the moon that broke off during that impact 4 million years ago. Luckily, there's no need to panic about it. When astronomers spotted this sudden moon piece, they quickly tracked its orbit. Turns out, it won't collide with us anytime soon. It's going to be our quasi-satellite for at least 300 more years, meaning it'll follow a path around the Sun that keeps it close to Earth without colliding. Its orbit is wild, though. It seems to be constantly looping around our planet in some pretty unique loops, moving closer and going away, up and down. And then somewhere in the 24th century, it will go even more crazy, switching to a horseshoe orbit, slowly going away from us. Could HO3 collide with us someday? Maybe, but that would happen over millions of years, when it would leave its current orbit and collide with Earth, Venus, or even the Sun itself. Or maybe entirely ejected from the solar system. Even though it's one of the closest asteroids ever discovered, It's also one of the smallest and most stable ones. This discovery also opens up some exciting ideas about life in the universe. We see that rocks can travel between celestial bodies. There is a theory that life could have been spread all across the universe by traveling on these rocks like on some space Ubers, or at least the building blocks of life like carbon. Maybe life even hitchhiked to our planet on rocks from Mars. HO3 probably doesn't carry any life, but the fact that it can travel for millions of years carrying stuff on it and feeling fine supports this theory. Astronomers want to send something to investigate HO3. Back in 2017, a group of students gave an idea of using a spacecraft for it. The China National Space Administration wants to send a robotic probe to HO3 somewhere in 2025. The robot should fly there, collect samples, and bring them back to Earth for study. Unfortunately, you can't see this asteroid in the sky with the naked eye. Its size is about 130 to 330 feet in diameter, so it would be too tiny and dim to see without a super powerful telescope. But there is an asteroid that you'll be able to see, and it will be insane. In 2029, a large asteroid will pass so close to Earth that it will be visible to the naked eye. Make sure not to miss it, because this is a once-in-a-thousand-year event. The asteroid is known as 2004 MN4, or Apophis for short. It's much bigger than HO3, about 1,210 feet wide. This will be the closest asteroid passage ever. This one actually caused some panic back in December 2004, all because there was a 2.7% chance that it could hit Earth in 2029. People were horrified. Even the name, Apophis, is inspired by an evil serpent from ancient Egyptian mythology. A huge monster that fought Ra and always tried to swallow the sun and destroy the planet. Luckily, when scientists got more data, they realized that it would pass pretty close to us in 2029, and we'd be able to see it in the sky. But then, it will just fly away like a chill asteroid. There was another worry though. That during its close pass, Apophis might travel through something called a gravitational keyhole. Basically, that it could travel through a specific narrow region of space which would accidentally alter its orbit. And then it would make an epic comeback in 2036, like the planet from the movie Melancholia. However, after some calculations, scientists ruled out this possibility as well. Apophis will still come quite close to us in 2036, but it will be about as far away as Venus is when it overtakes Earth. And then, Apophis and Earth will just go their own separate ways. On average, an asteroid the size of Apophis is only expected to hit Earth once every 80,000 years. And if it did hit us, it would completely destroy a huge area, causing earthquakes and tsunamis all around the world. But it wouldn't cause an apocalypse or anything like that. You'd only be able to see Apophis from Europe, Africa, and Western Asia. So if you want to see it, you might need to travel. The asteroid will look like a fast-moving star in the night sky, shining bright enough to be seen without any special equipment. It would be easy to spot at night, though city lights might make it harder to see. Now, can you imagine that these are not the only guys hanging nearby? Both HO3 and Apophis are part of the so-called Apollo orbit asteroids. These are the asteroids with orbits going around Earth, an entire group of dangerous fellas. Since they cross Earth's orbit, they have the potential to come close to or even collide with our planet. The first asteroid of this group to be discovered was 1862 Apollo, named after the Greek deity of the sun. It was first discovered in 1932, and the group was named after it. This one was even bigger, almost a mile in size. In fact, it's so huge that it even has its own tiny moon. Apollo crosses orbits of not just Earth, but also Venus and Mars. Fun fact, even though it was the first one of its kind, telescopes accidentally lost it out of view for over 40 years. So scientists went, oh well, let's just keep the count of things we can see. When Apollo was rediscovered in 1973, it wasn't the first asteroid on the list and got a big number in its name. Apollo will fly near us during the next hundreds of years. In 2075, it will be somewhere around Venus, but it should fly by as well. In any case, there's no need to worry, because astronomers are keeping a close track on these guys. If we were in any immediate danger, we'd have known. In order for an asteroid to totally destroy life on our planet, it should be bigger than 6 miles in diameter, like the one that helped to wipe out the dinosaurs 66 million years ago. But these guys are so crazy rare, we'd probably live on other planets by the time they arrive on Earth.
Okay, it seems scientists have come across a strange object in space, and they're not sure if it's a star or a planet. What we do know is that it's located 1,400 light-years away from us, and it makes us question what we thought we knew about the universe. Let me explain the dilemma here. We can tell if something is a star or a planet by considering the object's mass or the amount of stuff it has. Stars have a lot of mass, which gives them strong gravity that squeezes them tightly. Squeezing creates high temperatures inside them, causing them to shine brightly. Planets have less mass, so their gravity is weaker. They don't experience the same squeezing or high temperatures as stars. Instead, planets shine because they reflect the light from their stars, like our beautiful Earth does with our Sun, too. And this weirdo falls somewhere in between, since we consider it a brown dwarf. It's a special type of big, gaseous protostars. Brown dwarfs are usually like Jupiter in terms of their atmosphere, but they are much larger in size, about 13 to 80 times. If a brown dwarf has more than 80 times the mass of Jupiter, it can start burning regular hydrogen, just like a star. That's what usually makes stars shine brightly. But normally, brown dwarfs are not as hot as stars. Their inability to burn hydrogen has even earned them the nickname of failed stars. They burn at around 4,000 degrees Fahrenheit, which is cooler than most stars. But this object defies the norm. Its temperature measures an incredible 13,900 degrees Fahrenheit. Now let's put that into perspective. The hottest day in history was reported to happen in Death Valley, California, more than 100 years ago, with a temperature of 134 degrees Fahrenheit. People back then must have felt like they were melting along with everything around them. Now imagine getting closer to the Sun, like taking a trip to Venus. Venus can reach insane temperatures of 860 degrees. It's not only about the distance, though. Mercury is the planet closest to the Sun, but it's still colder than Venus. Venus is extremely hot due to the greenhouse effect. Did you know that Venus could have been a delightful place to live a long time ago? Or at least be home to any form of life. But at some point, it started to trap carbon dioxide and eventually created this thick, smoggy oven that doesn't release heat. And that's why it's so hard to explore. The longest a probe managed to last on Venus was 2 hours. But hey, that's longer than I can do at work, and then I melt. So yeah, then you get to the Sun. Its surface burns at an incredible 9,930 degrees Fahrenheit. And what's fascinating is that this weird brown star we're talking about is hotter than that. I mean, it's not hotter than the Sun's core, whose temperatures go up to 27 million degrees, but it's still very impressive and unusual for a brown dwarf to be this hot. At least, that's what everyone thought until they realized why it was happening. The brown dwarf is remarkably close to another star that falls into the category of white dwarfs. They're so close to each other that our mysterious star makes one orbit around its white dwarf friend in just 2.3 hours. Woo! How old we'd be over there! Since they're this close, they're tidally locked like our Moon and Earth. That means one side of this brown dwarf always faces the white dwarf, and the other side is forever in darkness. Because of all this, our brown dwarf is superheated on one side only. So its day side is what got us confused. While the temperature on the night side is what you would expect from a brown dwarf. But these extreme conditions won't last long. Such a hot temperature makes the molecules in the dwarf's atmosphere break apart into individual atoms. And while its molecules are falling apart, this brown dwarf is slowly disappearing. And if you think this brown dwarf is hot, what would you say about Eta Carinae? It's a star located about 7,500 light-years away from Earth, and it belongs to an elite group of stars we call luminous blue variables. One astronomer first noticed it in the 17th century, but back then, it was just a regular medium-bright star. Almost 200 years later, another astronomer was observing it, but this time it was a very bright star, one of the brightest ones in the sky. A few years later, it reached the highest level of brightness in a big event called the Great Eruption. When it happened, the star could be easily seen in the night sky. It released so much light, as much as is emitted in a supernova explosion. It remained like that for a couple of years, which is not what usually happens with exploding stars. After the party reached its peak, the star decided it was time to leave. It's still hesitating though, so it's still alive but dimmer than before. There's a nebula around Eta Carinae too. It is a shell made of gas and dust that formed during the Great Eruption. It even blocks some of the star's light. Eta Carinae is a binary star system. That means there are two stars that orbit around each other. One component has a temperature of about 26,500 degrees and the other 62,500 degrees. The main star in the Eta Carinae system, which is the more massive of the two, is 100 times heavier than our Sun. Because of its enormous mass, scientists predict that this star may eventually explode in a powerful event known as a supernova. But not for another several thousand years. So by now, you might have already guessed what the hottest thing in the universe is. Ta-da! A supernova. The supernova is what tells us that the life of a star has ended. We're talking about the most powerful explosions in space. They happen when a star that's between 8 and 40 times more massive than our Sun flops. Its core can no longer create enough energy through a process called fusion, so the star can't even handle its own gravity. It's like a stellar burnout, too much work a star can't handle, and its core just collapses. During a supernova, the temperatures in the star's core can get 6,000 times higher than in the core of the Sun. Or sometimes, a specific type of star called a white dwarf suddenly restarts its nuclear fusion, and bam, you get a supernova again. Kepler's supernova happened at the beginning of the 17th century, and it was the last really big supernova event we directly observed from Earth. On average, supernovas in our galaxy happen 3 times every century. I mean, we got a smaller supernova in 1987 too, when a blue supergiant exploded in one of the Milky Way's satellite galaxies, which we know as the Large Magellanic Cloud. This explosion was so strong, people could even observe it with the unaided eye, even though it was incredibly far, 168,000 light-years away from our home planet. What a topic for summer days, huh? But check this out. We can also talk about the hottest thing people have ever created, made in a surprising place, Switzerland. Nah, we're not talking about a super hot chocolate. A group of scientists there created a subatomic soup called a quark gluon plasma. In this experiment, the temperature got 250,000 times as hot as the Sun's core. The purpose of this experiment was to recreate the conditions that existed shortly after the Big Bang, when the universe was still in a state of chaos. Okay, let's get even more extreme. In theory, things can get even hotter. Have you heard of the Planck temperature? It's an insanely hot temperature with numbers so high we can't even imagine. A supernova is like tepid tea compared to this madness. And who even knows what the matter does at these temperatures? Okay, I'm done. Now we take you back to your regular universe. Bye now.
You're flying above Earth on the International Space Station at an altitude of 250 miles. You cast a glance out the porthole, and your eyes widen in surprise. There's some kind of bright blue flash just above nighttime Europe. It's like there was an explosion of some strange substance there. Such a strange luminous event was spotted by a French astronaut from aboard the ISS. And it wasn't an explosion at all. It was lightning, and was directed upwards. Until recently, this phenomenon was a kind of fairy tale among pilots. Scientists had heard their stories about lightning striking upward, and about red and blue flashes at high altitudes too. But there was no definitive proof of the existence of these luminous events. But they do exist, and are called sprites, elves, trolls, and ghosts. So how does ordinary lightning work? Masses of moist air in a cloud rub against each other and create static electricity. It would be almost the same if you danced in a wool sweater. It becomes charged with static electricity. And if you touch a metal doorknob, there's a discharge between your fingers and the door. There's your lightning. So a thundercloud builds up a strong negative charge. Sooner or later, a leader is born in the cloud. It's a bright thermo-ionized channel, or more simply, lightning. The leader moves toward the ground in steps of a few tens of feet, and it can accelerate to an average speed of 200,000 miles per hour. At that speed, you could make a trip around the Earth in just 7 minutes. But negative particles attract positive particles, and particles with opposite charges will tend to connect and compensate for each other. So, simultaneously with the negatively charged leader, the positive charge from the Earth begins its upward journey. The electric charge from the Earth connects with the negatively charged leader in one channel. This is when the brightest and loudest discharge happens. We call it lightning. It's this discharge that you hear as thunder. The main lightning doesn't strike from top to bottom, but from bottom to top. Yep, that is, the lightning is actually directed upward. It's as if the Earth is striking back at the thundercloud. And that charge can reach up to 30,000 amps. Your average wall outlet only has about 15 amps. And the record for the length of lightning is about 440 miles. That's more than the width of the state of Kansas. Meteorologists recorded such lightning in Brazil. It was a discharge between giant thunderclouds. And the longest lightning strike was recorded in Argentina. A single lightning strike there lasted 16.3 seconds. By comparison, you blink at 0.1 seconds. So we saw a regular lightning strike. The positive particles from the ground neutralize the negative particles in the cloud. But the cloud is still full of positively charged particles. They accumulate and wait for their time to create lightning. Once the charge reaches a critical point, the lightning cloud throws that charge dozens of miles upward. This is called a blue jet. It's exactly the same luminous event seen by a French astronaut aboard the International Space Station. The blue jets look like someone turned on a gas burner pointing upward. The positively charged blue jets neutralize at high altitudes with negatively charged particles, but people on the ground cannot observe blue jets. Thunderclouds obstruct the view, but they can be seen from an airplane. That's why, for a long time, commercial airline pilots were the only witnesses to this phenomenon. On board the ISS is also a great place to observe jets, as they are born at the very top of thick clouds and shoot dozens of miles upwards. But if you climb even higher, you can see this kind of bizarre lightning. It's a sprite. It looks more like a jellyfish. A cloud of red charge at the top and a bunch of little tentacles coming down. Now, normal lightning can have a temperature of about 54,000 degrees Fahrenheit, but you can touch a sprite with your hands. Unless, of course, you're afraid of a powerful electrical discharge. The sprite has about the same temperature as an energy-saving light bulb. All because sprites are born in the mesosphere. This is the layer of our atmosphere that starts at about 31 miles high. And it's the coldest place on our planet. On the ground level, where we live, the air is much denser. There are just more air molecules. They absorb heat from the sun's rays, and we feel comfortable. But the higher up we go, the fewer air molecules there are. At the altitude at which commercial airline planes fly, there's no longer enough air to accumulate that heat. You wouldn't even be able to breathe up there. That's why every airplane has oxygen masks for emergencies, and the temperature here is even colder than at the South Pole. In the mesosphere, there's almost no air, and the temperature here can be around negative 202 degrees Fahrenheit. And although the temperature of the lightning itself is high, in general, it's like if you poured a glass of boiling water into a huge barrel of cold water. The temperature won't change much. Sprites can only appear when paired with thunderclouds below. As a discharge occurs in a cloud, a sprite appears in the mesosphere. It tries to equalize the amount of charge in the atmosphere. So it's like these red flashes of lightning are trying to reach down to the thunderstorm. And a sprite itself can be as wide as the state of Massachusetts. And then there's a ghost. It can appear for the tiniest fraction of a second right after the sprite. It's a faint green glow, like an aurora. They were first discovered in 2014, and official confirmation by the scientific community only appeared in 2019. They're still poorly understood, but there's a hypothesis that ghosts have something in common with auroras. At least their color is green, and it may arise due to excited oxygen atoms. Sometimes we can spot trolls along with sprites. They look like pillars that support a sprite. It's a red glow at the end of the sprite's tentacles. The next moment, the troll releases a red streak down from itself. And if we climb even higher, we can see the elves. They only appear for 1 millisecond. It's a dim, flat glow that appears during thunderstorms in the ionosphere at an altitude of about 62 miles above sea level. Elves can be as wide as the distance between New York and Washington, D.C. Elves were first discovered during space shuttle flights in 1990. And these are pixies. They weren't discovered until 2000. Scientists observed bright, brief, luminous events for 20 minutes. Although they look like lightning striking inside a cloud, they have nothing to do with them. Pixies are smaller than 100 meters, which is about 330 feet. We shouldn't forget that any lightning is extremely dangerous for humans, and if you're caught in a severe thunderstorm, you need to leave its epicenter immediately. You can determine how far you are from the epicenter easily. The speed of light is much faster than the speed of sound. So, when lightning strikes, it takes a couple of seconds until you hear the thunder. So, you need to measure that interval. Lightning! Now count the seconds. Every second of thunder delay after lightning is about 1,150 feet. That's the distance a wave of sound travels in 1 second. So if the thunder delay after a lightning strike is 5 seconds, you're about 1 mile from the lightning. You can also tell if there will be a thunderstorm by the smell. The air before a thunderstorm seems unusually fresh. This is because the air currents bring in ozone molecules from the upper atmosphere. The same ozone protects us from harmful ultraviolet rays and transfers heat from the sun to the atmosphere. What we use to breathe is the oxygen of 2 atoms. Add 1 more and you get ozone. Ultraviolet light breaks down the 2 oxygen atoms and is absorbed by them. These broken atoms are then attached to the normal double oxygen atoms. When an ultraviolet beam strikes an ozone molecule, it knocks 1 oxygen atom out of the chain again. But ozone tends to regenerate, so the lost oxygen is reattached to other double atoms. But the ozone layer began getting damaged when humanity started emitting harmful gas into the atmosphere. Freon is to blame. It's the gas we were using in old refrigerators. The freon molecule contains harmful chlorine atoms. Ultraviolet rays knock this atom out of the molecule. Then that chlorine atom steals 1 oxygen atom from ozone, and we have a double oxygen molecule that can't regenerate and save us from the harmful ultraviolet rays. This causes a hole to appear in the ozone layer. The most famous ozone hole was over Antarctica, but when humanity banned the use of harmful chemicals, this hole began to recover. It's not that the hole will close completely, it will just return to the way it was before.
Usually, when we look at the photos of astronauts in space, we can see that they're sort of attached to the spacecraft. But there was one brave astronaut who took a wild step into the great unknown without any safety line connecting him to the shuttle. This brave man was Bruce McCandless, and he did that stunt back in 1984. How did he come back, you may ask? He did this cool trick using a nitrogen jetpack, which NASA called the Manned Maneuvering Unit. At first, he tried out some test maneuvers in the Challenger's payload bay, and only after he made sure it was alright did McCandless decide to go for it and glide a staggering 320 feet away from the shuttle. A bit of sad stats here. Out of the 430 people who have made the leap into space, 18 have sadly lost their lives, which gives us a fatality rate of just over 4%. With these numbers, it's safe to say that space shuttles are the least safe means of transport out there. Duh. Alright, let's make it a tad brighter. If we crunch the numbers a bit better, we can get a smaller percentage. But how? Well, 4% is a bit misleading because when we count, we take all the space flights. However, some people flew several times, which reduced the probability. With over 600 seats filled across 113 shuttle flights, the true fatality rate for shuttle missions is actually closer to 2%. Let's test your general knowledge now, shall we? So, what was the first living thing ever sent to space? If your answer is a monkey, you aren't right. Those who said dogs, sorry you guys, but it's not correct either. On the 9th of July 1946, fruit flies became the first living creatures to make it to space during a suborbital V-2 rocket flight. Then, on the 20th of February 1947, these little guys safely returned from their journey, opening the door for future human space exploration. Before, we sent to space mammals like the rhesus monkey, Albert II, in 1949, or the famous space dogs. Scientists spent a lot of time studying fruit flies to see how they reacted to radiation and the conditions of space travel. Researchers started using fruit flies for experiments back in the 1910s. Guess why? Because we humans share a lot of genes with these yucky pests. Imagine hearing some creepy music all of a sudden, when there's nothing but darkness around you and nobody is there to help you. Right, now imagine how elevated this experience was for astronauts who heard some creepy music in their space shuttle. Months before the moon landing, Apollo 10 astronauts were orbiting the moon, testing equipment, when they heard strange audio noises. Astronaut Eugene Cernan noted the eerie sounds, joking they were like weird music. At that moment, the astronauts didn't have contact with mission control. They were over the moon's dark side. Although the noises resembled something from a sci-fi film, NASA downplayed them as they were focused on the astronauts' mental health. Despite years of speculation, the source of the sounds remains unknown, with theories ranging from radio interference to charged particle activity. Cernan later remarked that they didn't take it seriously and didn't report it after the mission. Chances are, we've already received messages from new friends from other galaxies, but we just failed to understand them. In August 1977, some astronomers using the Big Ear radio telescope at Ohio University picked up a strange narrow-band radio signal from the constellation Sagittarius that lasted for 72 seconds. The signal buzzed at a frequency of 1,420 megahertz, which is significant because it matches the natural emissions from hydrogen. This frequency had been flagged by scientists almost 2 decades earlier as a likely choice for extraterrestrial civilizations trying to reach out to us. They dubbed it the WOW signal after one of the astronomers wrote "WOW" on their printout. We've never heard that signal again, and no one has been able to explain its origin satisfactorily. After spending about a month in space, astronauts start losing quite a lot of skin from the bottoms of their feet, especially those tough calluses they've built up over time. One astronaut even called mission control in a bit of a panic when he noticed a chunk of his heel drifting off in zero gravity. But no worries, as the old calluses peel away, new ones spring up from the tops of their feet. They need that grip to hold on to all the restraints, kind of like airborne trapeze artists. Going number 1 and seeing blood is as scary as it sounds, and yes, in the weightlessness of space, blood doesn't settle in the lower body in the same way it does on Earth. This can lead to some alarming situations on board. Natural urges are universal, regardless of location. There are 2 main reasons why astronauts are unable to use traditional toilets in space. First, water is an extremely valuable resource aboard a spacecraft. Second, there's no gravitational flow of water in space. The drinkable water on a space station is contained in pouches and is used accordingly. In a weightless environment, a specialized device with suction and disposable bags is used for waste collection, with the storage being replaced every 10 days. Additionally, spacecraft are equipped with complex systems designed to recycle and filter liquid waste, converting it back into usable water for the astronauts' daily needs. As if that wasn't enough, Spending an extended period floating around in space brings another challenge. The body may lose its bursa sacs, those handy little cushions that sit between our hip joints. While this may not pose an immediate issue in the zero-gravity environment, returning to solid ground can turn the simple act of sitting down, whether in a chair or on a toilet, into a real struggle. The fluid shifts that contribute to blood-related issues don't stop there. They can also wreak havoc on astronauts' sinuses, creating a constant feeling of congestion. It feels like living in a stuffy room all the time, where relief seems just out of reach. Thus, the challenges of long-term space travel add up, making the experience as daunting as it is thrilling. Another challenge astronauts run into is vision loss, also known as ocular syndrome, which sounds all sciencey. While the exact cause is still a bit of a mystery, it's thought that extra pressure on the brain can mess with both the retinas and optic nerves. And here's a fun fact: it mostly affects guys. By the way, you might assume that shutting your eyes in space means it's pitch black, but that's not the case. Because of high levels of radiation, astronauts can still see bright lights when they zip through certain parts of their orbit. It's a pretty strange phenomenon that keeps them on their toes, even with their eyes closed. Switching gears, let's talk about bone health in space. It turns out that being weightless can really take a toll on astronauts' bones. Like, they can lose up to 2% of their bone mass every month, which is pretty wild. But the good news? They've come up with new exercise routines that help fight off that bone loss. So, while space travel definitely has its challenges, researchers are working hard to keep astronauts in tip-top shape as they explore the universe. The Big Crunch is a cool theory about how the universe might end, and it's basically the opposite of the Big Bang. So, imagine the universe expanding for ages, but then it hits the brakes and starts collapsing in on itself, maybe even forming a huge black hole. Scientists are looking into this by checking out the universe's density. If it's too dense, such a collapse might really happen. At first, people thought that gravity would eventually take over and stop the expansion from the Big Bang. But then we found this mysterious thing called dark energy, which is actually speeding up the universe's expansion. Because of that, it seems like the Big Crunch is pretty unlikely. Right now, the evidence shows that dark energy is here to stay, so the universe will just keep on expanding forever.
So, Mars has several faces. No, really. Back in 1976, when the Viking 1 orbiter was checking out the red planet, it spotted something interesting, a big structure that looked like a human face. It was in the region called Cydonia. It soon became very popular. A bit later, we also discovered the so-called crown face in Libya Montes. Mars in general has a lot of strange structures on it. In 2022, we spotted a door-like structure there. NASA's Curiosity rover snapped some pictures of a rocky mound called East Cliffs on Mount Sharp. This mound has natural cracks in it, and one of them is about the size of a dog door, like something from an ancient Egyptian tomb. A lot of people hyped that story up. The image was shared widely on social media, making the crack look bigger than it really is. Some people think that it's hinting at extraterrestrial life. But after looking closely, NASA found out that it was just a narrow crack in the rocky terrain. These cracks and gaps are pretty normal in rocky areas, both on Earth and Mars. The crack formed naturally over time, maybe from wind erosion or Marsquakes. Mars is a gold mine of mysterious structures. Recently, we found some strange spiral shapes there. These are giant coils made of lava, and they look like big springs or loops. For years, we weren't sure whether Martian valleys were formed by lava or ice. These lava coils are shedding light on that mystery. Now, thanks to higher resolution images from NASA's Mars Reconnaissance Orbiter, researchers have spotted 269 lava spirals that can't be explained by ice-related activities. What's fascinating is these lava coils are like the ones we see on Earth, like those formed by Hawaiian lava flows. These spirals are so well preserved that they were easily overlooked before. They range from 16 to almost 100 feet wide, and are subtle, blending into the dusty Martian landscape. These coils can teach us a lot about Mars's composition, especially its crust and mantle. We still don't know much about those. But Mars isn't the only planet with strange structures on it. For example, Saturn, the gas giant of our solar system, has a fascinating feature at its north pole, a huge hexagon. This is a hexagon-shaped cloud pattern that's about 9,000 miles long, making it larger than the diameter of Earth. It's thought to be a jet stream made of gases moving very fast, at about 200 miles per hour. This hexagon was first spotted by the Voyager mission in the 80s, and later seen up close by the Cassini mission in 2006. The Cassini mission noticed a change in its color from blue to golden over time. There are different ideas about why Saturn has this thing. One theory suggests it forms because of the way winds move at different speeds near Saturn's poles. Similar shapes were created in lab experiments when liquids were rotated at different speeds. Another idea suggests that a slow-spinning stream of air, along with Saturn's special weather patterns, might be responsible. In 2020, we found that when storms are surrounded by winds swirling in the opposite direction, they can create a steady hexagon shape. So far, this is the most likely explanation. Saturn also got lucky with the bizarre moons. One of them is called Lepidus. This moon has a weird feature, a huge ridge that wraps around its middle like a giant belt. This basically makes it look like a giant walnut. Where's my nutcracker? This ridge is incredibly tall by our standards, around 8 up to 12 miles high and stretching 124 miles wide. It covers more than 3/4 of the moon's surface and is considered the third largest mountain range in the entire solar system. Now, we don't have a clue about how this enormous ridge formed. It's unlike anything seen on other planets or moons. There's one idea, though. The ridge might be the remnants of a dead moon. Let's say billions of years ago, a colossal impact shattered chunks of material off Lepidus. These pieces circled around the moon, forming a mini-moon or sub-satellite. And over time, the gravitational pull of Lepidus tore this mini-moon apart, creating a ring of debris around it. As the debris from this ring fell back onto Lepidus, it built up the massive ridge we see today. They think this process happened quickly, maybe over centuries. Saturn's gravity didn't interfere because, luckily, Lepidus was quite far away from it. If Lepidus was closer to Saturn, its moon might have been pulled away. But we do need more simulations to see if this theory is true. Titan, another one of Saturn's moons, also has some weird stuff going on in its methane seas. Scientists have spotted these strange bright spots called magic islands that seem to pop up and disappear over time. We have no idea what they are. Titan's atmosphere is packed with complex organic molecules that clump together and fall to its surface like snow. These magic islands might be snow clumps that soak up methane and sink very slowly. But there's a problem. In water, molecules stick together, which is why stuff can float on top of it. But methane is different. It likes to grab onto other molecules, so it makes any solid thing sink immediately. Yet, these magic islands don't sink. There's a theory that these islands might be like sponges made of ice with lots of holes. When pieces of this holy ice come loose from the edge of the lake, they can float on Titan's seas for a bit before going down under. There are also other ideas, like bubbles of nitrogen gas or waves caused by wind. We need more research to know for sure. Moons like to be weird. Just look at our own one. In 1971, we found a patch with missing soil on our moon, and it looks like a blue lake. They call this mysterious spot Ina. We first spotted it during the Apollo 15 mission in 1971. Later, the Apollo 17 mission took clearer pictures of it. This spot, shaped like a bluish D letter, is one of the weirdest things on the moon. The color comes from special rocks rich in titanium called basalts. These rocks cover Ina's floor and make it look blue. There are also bluish areas near the edges of the mounds inside Ina. Ina is unique and probably has a long history. It might have had volcanic activity, with mounds that are about 3.5 billion years old. It's similar to the surface age of the volcanic field that surrounds Ina. Now, our moon has its own face, just like those on Mars. There's an area near the moon's south pole that looks like a face. but it's just a bunch of craters and shadows that happen to make an image resembling a face when seen from far away. These craters have been there for billions of years and cover about 16% of the Moon's surface. Some of these craters might even have water and ice inside of them. You might be wondering why there are so many faces in our solar system. Well, that's because our brains are wired to recognize faces, even when there aren't any. It's a phenomenon called pareidolia. Our brains try to make sense of shapes, so when we see something that looks a bit like a human, our brain turns it into one because it's familiar. Like when you see a shadow figure on a chair with clothes, or even on Mercury. Some people see shapes like Mickey Mouse. So don't worry, it's not extraterrestrial life. It's our brains that play tricks on us, making us see familiar shapes like faces even where they don't really exist.
Earth's magnetic field hides a fascinating story. It turns out that it's getting weaker day by day. In fact, it's been doing so for the last 3,000 years. And if this trend continues, we could be in for some trouble within a millennium. What's the big deal? Well, picture this. Magnetic north becomes south, and vice versa. Pretty wild, right? When this happens, our planet's protective magnetic shield might weaken, allowing more cosmic rays to hit us. These high-energy particles from the universe can cause electronic malfunctions in our satellites and produce elements that could be harmful to us. The last time a polarity reversal occurred was between 772,000 and 774,000 years ago. Thankfully, humanity has some pretty smart people on the case who are investigating the history of Earth's magnetic field. They take cores of sediments from the seafloor and study the magnetization of fossils to figure out when these reversals occurred in the past and when they might happen again. Another group of researchers is studying the South Atlantic Anomaly, SAA, a vast region of Earth's magnetic field that is about 3 times weaker than the field at the poles. Using data from multiple satellites, they are trying to figure out what's causing the SAA and how it might change in the future. This could give us a glimpse into how a weakened magnetic field can affect our satellites and our planet. Sure, our generation won't be here to witness these changes, but it does make you wonder what that planet might look like upside down. Magnetically, that is. NASA's astronomers have also announced that in 4 billion years, the Milky Way galaxy is going to get a major glow-up. After a cosmic collision that will shake things up. I'm not talking about a small fender bender here, I'm talking about a titanic collision with our neighboring Andromeda galaxy. Humanity will have to hold on to its space helmet for this one, because the sun might get flung into a new region of the galaxy. However, our Earth and solar system probably won't be seriously affected. Sounds difficult to believe, so how come? NASA's Hubble Space Telescope did some hardcore measurements of Andromeda's motion. Although the galaxies will plow into each other, the stars inside each galaxy are so far apart that they won't collide with other stars during the encounter. However, the stars will be thrown into different orbits around their new galactic centers. According to simulations, our solar system will probably be tossed much farther from the galactic core than it is today. Set your telescopes aside. You don't need to start counting down the years. This event is likely scheduled in about 4 billion years, so chances for us to witness it are 0. Saturn is losing its rings. Thankfully, we won't be here to witness this sad event either. Apparently, the rings are being pulled into Saturn as a dusty rain of ice particles, all under the influence of Saturn's magnetic field. According to NASA's research, the ring rain is draining an amount of water products that could fill an Olympic-sized swimming pool from Saturn's rings every half an hour. The entire ring system will likely be gone in 300 million years. Scientists believe we should consider ourselves lucky to witness Saturn's ring system at all, as it seems to be in the middle of its lifetime. But if you think about it that way, that rings around planets are all temporary, there's a chance we've just missed out on the giant ring system of Jupiter, or those of Uranus and Neptune. These planets have only thin ringlets around them these days. Scientists have long debated whether Saturn was formed together with its rings or if the planet acquired them later in life. The new research favors the second scenario, indicating that they are unlikely to be older than 100 million years, while Saturn itself is around 4.5 billion years old. What caused the rings to appear in the first place? Well, there are a few theories. One of them suggests the rings could have formed when small, icy moons in orbit around Saturn collided. Perhaps their own orbits were messed up by a gravitational tug from a passing asteroid or comet. Who knows what humans might end up looking like in the future? It's unlikely we'll see any major changes in our lifetime. But let's take a journey to the future and ponder what we might evolve into. Will we become cyborgs with all sorts of cool machine implants? Or maybe we'll become a hybrid species of biological and artificial beings. To understand our future evolution, we gotta take a peek at our past. 1 million years ago, Homo sapiens didn't even exist. There were a few other similar species though, like the Neanderthal. Fast forward to today, and humans have become taller and sturdier. Maybe in the future we'll become smaller to conserve energy, as it's predicted that our planet will get more crowded. Speaking of crowded planets, living in these new conditions means we have to adapt, and fast. We're constantly interacting with lots of people, and remembering names is becoming a crucial skill. Luckily, technology might help us out with brain implants that will improve our memory. In the future, we might also have more noticeable technologies as part of our appearance. Imagine having an artificial eye with a camera that can read different frequencies of light. While predicting 1 million years into the future is pure speculation, we can use bioinformatics to make some predictions about the immediate future. Demographic trends suggest that urban areas will become more genetically diverse, while rural areas will become less diverse. And what about space? If we end up colonizing Mars, our bodies could change due to lower gravity. Maybe we'll have longer arms and legs, or even insulating body hair like our Neanderthal cousins. In the future, our moon is also going to witness some dramatic changes. We'll miss these ones too. In about 5 billion years, things are gonna get really interesting in this corner of the universe. For now, the sun is chilling in its main sequence phase, just burning hydrogen like nobody's business. In the future, during the red giant phase, the sun is gonna puff up like a balloon until its atmosphere reaches out and engulfs our beloved Earth and Moon. Our natural satellite, which is already moving away from Earth, is gonna get warped around the sun's influence. Its orbit will get all wonky, and it'll end up closer to Earth during the new moon phase than during the full moon. And that's not even the worst part. If left alone, the moon would keep on moving away from Earth until it'll need almost 50 days to orbit us. As the sun continues with its own journey, its atmosphere will drag on the moon and cause its orbit to decay. Eventually, the moon will get torn apart into a stunning ring of debris circling Earth. We're talking about all its mountains, craters, and even the footprints and flags we left there, all scattered throughout the debris field. There's a chance the sun will shed enough mass to spare Earth and the moon from total annihilation. Or if we're really lucky, the sun will lose 20% of its mass and we'll be safe and sound. It's all just theory right now. We haven't seen a red giant star during this phase. The universe itself might go completely dark one day too. Scientists can't predict it with absolute certainty, but they can make some educated guesses. Right now, our universe is 13.77 billion years old, and it's still churning out new stars left and right. It's said that eventually, after about 1 trillion years, the last star will be born. That final star will be a little guy, a red dwarf just a fraction the size of our Sun. These stars are champs at living long lives, slowly sipping on hydrogen to keep their fusion reactions going. But even they can't last forever. Fast forward about 100 trillion years, and the last light will go out. The universe will be dark and lonely, but thankfully, we won't be here to watch it all fade away.
Venus most likely used to be covered with oceans, from 30 to 1,000 feet deep. Also, some water was locked in the soil of the planet. On top of that, Venus had stable temperatures of 68 to 122 degrees Fahrenheit, which, you have to admit, was quite pleasant and not that different from the temperatures on Earth nowadays. So, what I'm getting at is that for 3 billion years, right until something irrevocable happened 700 million years ago, Venus could have been habitable, but now it's not. The Moon is the second brightest object in our sky. At the same time, among other astronomical bodies, it's one of the dimmest and least reflective. Our natural satellite only seems bright because it's so close to Earth. For comparison, our planet looks much brighter when you look at it from space. It's because clouds, ice, and snow reflect way more light than most types of rock. Triton, Neptune's moon, has all its surface covered with several layers of ice. If this satellite replaced our current moon, the night sky would get 7 times brighter. Neutron stars are some of the smallest, yet most massive objects in space. They're usually about 12 miles in diameter, but are several times heavier than the Sun. Oh, and they also spin about 600 times per second, far faster than your average figure skater. Saturn is the least dense planet in the solar system. It has 1/8 the average Earth's density. And still, because of its large volume, the planet is 95 times more massive than Earth. A transient lunar phenomenon is one of the most enigmatic things happening on the Moon. It's a short-lived light, color, or some other change on the satellite surface. Most commonly, it's random flashes of light. Astronomers have been observing this phenomenon since the 1950s. They've noticed that the flashes occur randomly. Sometimes they can happen several times a week. After that, they disappear for several months. Some of them don't last longer than a couple of minutes, but there have been those that continued for hours. The year was 1969, one day before Apollo 11 landed on the Moon. One of the mission participants noticed that one part of the lunar surface was more illuminated than the surrounding landscape. It looked as if that area had a kind of fluorescence to it. Unfortunately, it's still unclear if this phenomenon was connected with the mysterious lunar flashes. Trash isn't just a problem in Earth's oceans, cities, and forests. There is a thing called space junk, which is any human-made object that's been left in space and now serves no purpose. There's also natural debris from meteoroids and other cosmic objects. There are currently over 500,000 pieces of space debris orbiting the Earth at speeds high enough to cause significant damage if they were to collide with a spacecraft or satellite. NASA does its best to track every single object to ensure that missions outside Earth can reach their destination safely. Our Sun is insanely massive. Want some proof? 99.86% of all the mass in the solar system is the mass of the Sun. In particular, the hydrogen and helium it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. The Sun's temperature is hotter than the surface of a star. The surface temperature reaches 10,000 degrees Fahrenheit, but the upper atmosphere heats up to millions of degrees. If someone could dig a tunnel straight into the center of the planet and out the opposite side, and you were adventurous enough to jump into it, it would take you 42 minutes to fall to the other side. You'd speed up as you fell, reaching maximum speed by the time you reached Earth's core. After the halfway point, you would then fall upwards, getting slower and slower. By the time you reached the opposite surface, your speed would be back to zero. Unless you managed to climb out of the hole, you'd immediately start falling again, back down or up to the other side of the planet. This trip would go on forever, all thanks to the weird effects of gravity. Hey, might be a fun way to spend an afternoon. There might be more metals, for example, titanium or iron, in lunar craters than astronomers used to think. The main problem with this finding? It contradicts the main theory about how the moon was formed. That theory says that Earth's natural satellite was spun off from our planet after a collision with a massive space object. But then, why does Earth's metal-poor crust have much less iron oxide than the moon's? It might mean the moon was formed from the material lying much deeper inside our planet. Or these metals could have appeared when the molten lunar surface was slowly cooling down. Or maybe, as they've been saying for centuries, it's made of green cheese. Earth could have been purple before it turned blue and green. One scientist has a theory that a substance existed in ancient microbes before chlorophyll. That thing that makes plants green evolved on Earth. This substance reflected sunlight in red and violet colors, which combined to make purple. If true, the young Earth may have been teeming with strange purple-colored critters before all the green stuff appeared. The highest mountain in the solar system is Olympus Mons on Mars. It's 3 times as high as Mount Everest, the Earth's highest mountain above sea level. If you were standing on top of Olympus Mons, you wouldn't understand you were standing on a mountain. Its slopes would be hidden by the planet's curvature. Astronomers have found a massive reservoir of water in space, the largest ever detected. Too bad it's also the farthest, 12 billion light-years away from us. The water vapor cloud holds 140 trillion times as much water as all the Earth's oceans combined. What are we supposed to do with that information? Venus spins at its own unhurried pace. A full rotation takes 243 Earth days, and it takes the planet a bit less than 225 Earth days to go all the way around the Sun. It means a day on Venus is longer than a year. There's very little seismic activity going on inside the Moon. Yet many moonquakes, caused by our planet's gravitational pull, sometimes happen several miles below the surface. After that, tiny cracks and fissures appear in the satellite surface, and gases escape through them. Hey, they sometimes escape from me, too. Now, Mars is the last of the inner planets, which are also called terrestrial since they're made up of rocks and metals. The red planet has a core made mostly of iron, nickel, and sulfur. It's between 900 and 1200 miles across. The core doesn't move. That's why Mars lacks a planet-wide magnetic field. The weak magnetic field it has is just 1/100th% of the Earth's. When the planets in the solar system were just starting to form, Earth didn't have a moon for the longest time. It took 100 million years for our natural satellite to appear. There are several theories as to how the moon came into existence, but the prevailing one is the fission theory. Somebody went fishing and caught the moon? Actually, no. The fission theory proposes that the moon was formed when an object collided with Earth, sending particles flying above. Gravity pulled the particles together, and the moon was created. It eventually settled down on the Earth's ecliptic plane, which is the path that the moon orbits. So, looks like the green cheese is off the table now. The largest single living thing on Earth turns out to be a mushroom in Oregon. This enormous honey mushroom lives in Malheur National Forest and covers an area of 3.7 square miles. It could be as much as 8,500 years old. You could be forgiven for missing it, though, since most of it's hidden underground. When the roots of individual honey mushrooms meet, they can fuse together to become a single fungus, which explains how this one got so big. If you could gather all that mushrooming stuff into one big ball, it could weigh as much as 35,000 tons. That's about as heavy as 200 gray whales. Hey, that's a whale of a mushroom. Hehe. The largest asteroid in the solar system is called Vesta, and it's so big that it's sometimes even called a dwarf planet. A trip to the nearest star, apart from the Sun, would take you 5 million years on a commercial airplane. That's what I call a long-haul flight. Space isn't supposed to be black. There are stars everywhere. Shouldn't they light up everything around? Well, you don't see stars wherever you look because some of them haven't existed long enough for their light to reach Earth. A day on Uranus lasts 17 hours, 14 minutes, and 24 seconds. But get this, the planet has a tilt of around 98 degrees, and that makes a season on the gas giant last 21 Earth years. Now, some scientists believe that our planet used to have an additional satellite, According to their research, a small celestial body about 750 miles wide orbited Earth like a second moon. It most likely crashed into our main satellite later on. Such a collision could explain why the two sides of the moon look so different from each other, one being heavily cratered and rough. Or it could be the green cheese. On August 20th, 1977, the most ambitious space mission took off from Earth. The main goal of Voyager 2 was to study the outer solar system up close. It became possible because of a rare alignment of planets. Voyager 2 was supposed to study all the gas giants of the solar system: Jupiter, Saturn, Uranus, and Neptune. Astronomers also hoped it would be able to find and explore the edge of the solar system. Since Voyager 2 was built for interstellar travel, the probe was equipped with a large 12-foot wide antenna. It allowed the spaceship to send the data it gathered back to Earth. During its journey, the space probe discovered a 14th moon of Jupiter. Voyager 2 was the only spaceship to study all 4 giant planets from up close. It was the first human-made object to fly past Uranus, where it found 2 new rings and 10 new moons. Voyager 2 also flew by Neptune and noticed its great dark spot. That's a colossal spinning storm in the planet's southern hemisphere. The storm is the size of Earth and moves at a speed of 1,500 miles per hour. These winds are the strongest ever recorded on any planet of the solar system. In the history of space exploration, only 5 spacecraft have managed to leave the gravitational pull of the solar system. Those were Pioneer 10 and 11, Voyager 1 and 2, and New Horizons. People launch thousands of objects into space. These objects easily overcome Earth's gravity. But the Sun is around 300,000 times as massive as our home planet. That's why its gravitational pull is way more difficult to fight. Even more impressively, Voyager 2 is the second human-made object in history to reach the space between stars after passing through the heliosphere. That's a bubble of magnetic fields and particles produced by the Sun and protecting the solar system. 2 years after its launch, Voyager 2 started transmitting the first images of Jupiter. The space probe provided scientists with much-needed information about Io and Europa, some of the largest of Jupiter's moons. Then the space mission passed by the gas giant itself. The distance between the spacecraft and the planet was around 400,000 miles. That's when the probe noticed some changes in the shape and color of the Great Red Spot. It's an enormous, long-lived storm system, like a hurricane on Earth, but much, much larger. 2 years later, Voyager 2 reached Saturn. It discovered spokes and kinks in some of the planet's rings. While the spacecraft was flying behind and up past the gas giant, it passed through the plane of Saturn's rings. At that time, Voyager's speed was around 8 miles per second. For several minutes, the probe was hit by thousands of micron-sized grains of dust. This kept shifting the probe's direction, and its control jets had to fire many times to stabilize the vehicle. After Voyager 2 explored Uranus and Neptune, it headed out of the solar system. Its instruments were put in low power to save energy. In August 2007, the spacecraft passed the terminal shock. It's the boundary marking the outer limit of the Sun's influence. Here, the solar wind slows down. In the summer of 2013, the probe reached interstellar space. Now, when it comes to sending and receiving signals in space, there are 3 factors you should keep in mind: distance, power, and time. The farther away a spacecraft is, the farther a signal has to travel before it reaches it, and the longer it takes for this signal to catch up with the spacecraft. And when it finally gets there, it's extremely weak. Another problem is that once the spacecraft is launched, it can't be upgraded. It's literally stuck with the technology it was outfitted with. Plus, such spaceships as Voyager 2 are powered by radioactive fuel. When special material radioactively decays, it releases heat that gets converted into electricity. Unfortunately, the more material decays away, the less power the spacecraft has for receiving and transmitting radio signals. Despite this issue, we haven't lost the connection with Voyager 1 and 2. That's because new and more powerful technologies appear on Earth. Signals people send can reach much farther than before. That's why it was possible to stay in touch with Voyager 2, which entered interstellar space in 2018 and has already traveled almost 12 billion miles away from Earth. But in March 2020, the main piece of equipment that allowed scientists to exchange signals with the spaceship was switched off. After the communication with the spacecraft stopped, NASA spent around 11 months upgrading its deep space network and installing new hardware. The DSN is an international array of huge radio antennas that help astronomers on Earth communicate with interplanetary missions. These antennas are located in California, Madrid, and Canberra. The one used to keep in touch with Voyager 2 is a 230-foot wide dish in Canberra. This is the only equipment that can send commands that can reach the probe. This antenna, known as DSS-43, started operating in 1972, 5 years before Voyager 2 and 1 were launched. At that time, it was only 210 feet across. Since then, the dish has received a lot of repairs and upgrades, but these 11 months were the longest the antenna was offline. In October 2020, the antenna was finally ready for a trial after all the upgrades and repairs. The mission operators sent a set of commands to Voyager 2, and after many months of radio silence, the spacecraft returned the signal. The probe confirmed it had heard the call. After that, the spacecraft carried out the commands. While the dish was offline, the mission operators could actually receive scientific data and health updates from Voyager 2. Astronomers kept getting data from interstellar space, the region outside the Sun's heliosphere, but they couldn't send any commands to the probe since it had traveled too far away from Earth. The upgraded antenna received 2 new radio transmitters, and it was done just in time. One of the transmitters, that was used to communicate with Voyager 2, hadn't been replaced in almost 50 years. The antenna also got new cooling and heating equipment and other electronics necessary to support the advanced transmitters. Now, a curious thing about the Deep Space Network is that its radio antennas are positioned in a very precise way. They're spaced equally around the globe. This way, almost any spacecraft can stay in touch with at least one facility at all times. But Voyager 2 is an exception. In 1989, it made a close flyby of Triton, Neptune's moon. It was the only close encounter people had with the 8th planet of the solar system and its moon. By the way, Triton is the largest known object that is believed to be born in the Kuiper Belt. That's a donut-shaped ring around the Sun full of icy objects. Voyager 2 discovered Neptune's ring system and its tiny inner moons. The probe also gathered a lot of amazing information about Triton. For example, it became clear that the moon is covered in cryovolcanoes. Instead of spewing molten rock, these volcanoes spit ice consisting of water, ammonia, and methane. When the New Horizons spacecraft flew past Pluto more than 25 years later, it discovered the same phenomenon on the dwarf planet. Anyway, to make this detour, Voyager 2 had to travel over the gas giant's North Pole. But this changed the probe's trajectory, deflecting it southward relative to the planes of the planets. Since then, Voyager 2 has been moving in that direction. And now, the spacecraft is so far away that it's out of reach of the radio antennas in the Northern Hemisphere, those in Madrid and California. This makes DSS-43, which is located in the Southern Hemisphere, the only dish powerful enough in broadcasting just the right frequency to send commands to Voyager 2. Voyager 1, the probe's faster-traveling twin, didn't change its trajectory. After passing by Saturn, it took a different path. That's why now it can easily communicate with the 2 facilities in the Northern Hemisphere. The upgrade the Canberra Deep Space Communication Complex has gone through can also benefit other space missions. For example, the Mars Perseverance rover that landed on the Red Planet on February 18, 2021. The dish will also be crucial for exploring other planets and the Moon. Attention, attention! Something very exciting is going on Saturn. It's called a spoke season, and no, the planet isn't turning into a giant gaseous wheel. Let me tell you more about this phenomenon. Each year, NASA's Hubble Space Telescope devotes some of its time to observing Saturn, a gas giant, like me, the second largest planet in the solar system. And this space body always has something new to surprise us with. For example, look at one of the latest images of the gas giant. See those smudgy spokes? They mean that Saturn's spoke season is starting. Like our planet, Saturn is tilted on its axis. That's why it has 4 seasons. But since the orbit of the gas giant is much larger, each of these seasons lasts about 7 Earth years. Keep this in mind, it's important. Now, the next thing we need to talk about to understand the concept of the unique spoke season on Saturn is the equinox. On Earth, it's the moment when the sun is exactly above the equator of the planet, and day and night are of the same length. But on Saturn, it's something a bit different. An equinox occurs when Saturn's rings are tilted edge-on to the sun. And even though equinoxes on Saturn happen every spring and fall, just like on our planet, they actually occur very seldom, roughly once in 15 Earth years. That's why astronomers are so excited about this event. Now look, there are 2 smudgy spokes in this ring. It's called Ring B on the left of the picture. They resemble the spokes on a bicycle. The shading and shape of spokes vary. They may seem dark or light, it depends on the angle and illumination. Sometimes they might look like blobs instead of something with a classical radial spoke shape. They also don't last long, but more and more will start to appear the closer we're to May 6, 2025. That's when the autumnal equinox on Saturn will occur. But what causes the spokes? Astronomers think it might be the gas giant's magnetic field. When a planetary magnetic field interacts with the solar wind, it creates an electrically charged environment. On Earth, this results in northern lights, also called aurora borealis. And if we speak about Saturn, the tiniest icy ring particles might get charged too. And it probably temporarily levitates these particles above the larger boulders the rings consist of. For the first time, the spokes in Saturn's rings were spotted by NASA's Voyager mission. It happened in the early 1980s. At the time, we didn't know that these spokes were a seasonal phenomenon. Voyager 2 just passed by the planet and then sped on. To figure out what these spokes were and how they functioned, astronomers needed a space telescope that could observe Saturn's rings from afar, like Hubble. The latest equinox on Saturn occurred in 2009. At that time, NASA's Cassini space probe was traveling around the gas giant. It sent many amazing images back to Earth. They quickly proved that the spokes weren't caused by gravitational interactions with Saturn or the influence of the gas giant's moons or small moonlets, which make up the planet's rings. It was the year 2005 when Cassini confirmed that the spokes were related to Saturn's magnetic field. That mission was finished in 2017. Now Hubble keeps its long-term monitoring of the changes on and around Saturn. Despite all the observations, astronomers still can't predict the beginning and duration of the spoke season. Luckily, Saturn's prominent rings are a perfect laboratory for studying this phenomenon. Because even though other gas giants in the solar system also have rings, those are not so visible, and scientists don't know whether spokes occur on those planets. But these spokes aren't the only exciting space phenomenon. Our solar system is a fascinating place, that's why. If you were standing at the Martian equator barefoot, your feet wouldn't get cold. The temperature there would feel like on a sunny spring day on Earth. But you'd have to wear a hat. At the height of your head, it would be freezing cold. Now Venus spins backward compared to most other planets in the solar system and the Sun itself. One of the explanations astronomers have come up with is a collision with some solid object, for example an asteroid, that happened in the past. Jupiter's moon Io has hundreds of volcanoes, which makes the satellite the most volcanically active object in the solar system. The moon also has a weird yellowish surface. It looks blotted and resembles a pepperoni pizza. Yum. Europa, one of Jupiter's 4 biggest moons, is covered in ice. This ice shell can be 10 to 15 miles thick. It also has some smooth patches, so if you're into ice skating, you would like it there. If you lump together all the known asteroids in the solar system, their total weight would still be smaller than 10% of the mass of our moon. Scientists believe that Mercury might still have a partially molten core. It could explain why Mercury has a magnetic field, even if it's just 1% as strong as Earth's. Mercury's core takes up around 42% of the planet's volume. Mercury also has wrinkles. When its iron core was cooling, the planet's crust contracted. It made the surface of the planet uneven. These wrinkles are called lobate scarps. The biggest of these scarps can be hundreds of miles long and up to a mile high. Uranus is the only planet in the solar system to rotate on its side. The reason might be an ancient mega-powerful collision with an Earth-sized object, but so far it's just a theory. Mars might get a set of rings of its own in the next 70 million years. Its largest moon, called Phobos, is orbiting closer and closer to the planet. One day, it's likely to get broken apart by the gravitational pull of the red planet and turn into a ring that can last for millions of years. I won't be around then, so I'll just take their word for it. Scientists think that the moon's surface has more craters than Earth's because it doesn't have so much natural activity going on. Winds, rains, earthquakes, and erosion keep altering the surface of our planet, but the moon has almost no weather to change its appearance. Saturn is the most flattened planet in the solar system. It's squished at the poles, and any point on the equator is about 4,000 miles farther from the center of the planet than the poles. The Hubble Space Telescope weighs almost as much as 2 male African elephants and is as long as a big school bus. Yeah, that's a launch I'd love to see. 2 elephants in a school bus. It's made almost 1.5 million observations since it was launched in 1990. Astronomers have used this data to write about 15,000 scientific papers. Everything on Earth and everything people can see in space with the help of telescopes is normal matter. It's made up of atoms and molecules and adds up to less than 5% of the universe. Almost 68% of the universe is dark energy, and the remaining 27% is dark matter. Does that really matter? As a matter of fact, it does. Saturn has a mysterious vortex swirling over the planet's south pole. The whole thing resembles an enormous hurricane-like storm, measuring almost 5,000 miles across. That's 2/3 the diameter of Earth. What confuses astronomers is that although the phenomenon looks like a hurricane, it doesn't behave like one. Saturn is also the only planet in the solar system that's less dense than water. In other words, if you found a bathtub huge enough to fit this gas giant, it would float there like a rubber duck. Earthquakes on the moon don't occur as often as on our planet, but when they do, it happens closer to the center of the satellite. Scientists think moonquakes might be caused by the gravity of Earth and the Sun. One of Saturn's moons, Apophis, has bizarre two-tone coloring. The difference between the moon's two hemispheres is great. One of them is light and the other is eerily dark. Scientists haven't figured out this mystery yet. Now, the only asteroid belt in the solar system astronauts know about is between Mars and Jupiter. There are thousands of asteroids in this area. They're irregularly shaped solid objects of different sizes, but all of them are way smaller than a planet. Scientists have analyzed the chemical content of some meteorites found in the Sahara Desert, Antarctica, and other places. Some of the rocks turned out to have a Martian origin. Others arrived from the Moon or the asteroid belt between Mars and Jupiter. Ooh, space rocks. So we can also say, space rocks. Yeah, we could say that. Uh-oh. Something is nearing the surface of the planet. It looks like a fireball, hurtling closer and closer at a truly incredible speed. Soon, it becomes obvious that the collision is inevitable. Bam! The impact leaves a huge crater. It evaporates thousands of cubic miles of solid rock, and it also sets off a series of terrible natural disasters. Yeah, I know what you're thinking. You believe I'm talking about the catastrophic collision that occurred around 66 million years ago on Earth. You know, the one that's responsible for the extinction of non-avian dinosaurs and 3/4 of other life forms on our planet? But no, the disaster I'm talking about happened on a different planet. Scientists think that our close neighbor, Mars, once experienced the same catastrophe that struck Earth. It happened around 3.4 billion years ago. An asteroid collision might have caused a mega tsunami on the red planet, similar to the one that caused the Chicxulub impact on Earth. Scientists have identified an impact crater on Mars that was probably left by a comet or asteroid collision with the surface of the planet. Most likely, the space body landed in an ocean in the Martian northern lowlands, and the impact was so powerful that it caused a mega tsunami. Before the latest studies, the exact location of the impact crater wasn't verified. It was just a theory. To confirm it, a team of astronomers simulated a comet and asteroid collision in the area where they supposed the impact crater was. They even named this crater Paul. Paul is 68 miles across and lies in a region that is almost 400 feet below the supposed sea level. Anyway, the simulations formed several craters of the same size as Paul. One of the simulations claimed that these craters had been left by a 5-mile-wide asteroid that had encountered strong ground resistance. The other simulation showed that the craters had been caused by a bit smaller asteroid that met a weaker ground resistance. But according to both simulations, the impact crater was almost 70 miles in diameter, and the collisions produced mega tsunamis up to 900 miles away from the center of the impact site. The simulations also helped scientists estimate the height of the tsunami. It was about 820 feet tall, almost as tall as the Eiffel Tower. The authors of the study also suggest that the Paul crater might be similar to the Chicxulub impact crater on our planet. The Chicxulub asteroid, as we now know it, is believed to come from the outer reaches of the solar system. This space body was at least 6 miles across. It crashed into the shallow seawaters near the Yucatan Peninsula. This splashdown was so powerful that it left its signature on the entire face of the planet. In 2021, researchers found out that the collision had carved mega ripples into Earth's crust in the region of modern-day central Louisiana. An even newer study suggests that the asteroid also triggered a tsunami so devastating it eroded seafloor sediments half a world away. The team of scientists remodeled the events of the first 10 minutes after the impact, and the models showed that the asteroid had produced waves up to 30,000 times greater than one of the largest tsunamis people have ever recorded, the Indian Ocean tsunami that hit Indonesia in 2004. The collision displaced so much water that it created a wave almost a mile high. That's like 2 Burj Khalifas, which is the tallest construction in the world, stacked one on top of the other. And of course, all that empty space didn't stay empty for long. The ocean gushed back to fill the crater. But in the process, it only ricocheted off the crater's rim, which produced even more waves. After that, tsunami waves that were more than 33 feet tall traveled around the world at a speed of 3 feet per second, lashing at all coastlines on their way. Imagine a 3-story building rushing up to you. No wonder the largest and fastest-moving waves occurred near the impact area in the open waters of the Gulf of Mexico. Those rose more than 330 feet tall, which is taller than the Statue of Liberty, and moved at a speed 10 times greater than more distant tsunami waves. But back to the red planet. Some experts think that not 1 but 2 mega tsunamis could happen on Mars. They could be triggered by a pair of meteor impacts that were several millions of years apart. Between these 2 collisions, Mars went through a period of climate changes. As a result, liquid water on its surface turned into ice. In other words, the first asteroid impact most likely produced waves composed of liquid water, and the second tsunami was probably formed by rounded chunks of ice water. By the way, the largest asteroid to have ever crashed into Earth might not actually be the one that ended dinosaurs. A much more catastrophic collision likely happened about 3.5 billion years ago. New evidence scientists found in northwestern Australia suggests that the asteroid I'm talking about was 12 to 18 miles across. It struck Earth at an immense speed, releasing an unimaginable amount of energy. Now, this made me think, what if something like that happened these days? More than 30,000 objects that are circling Earth these days could potentially crash into our planet. NASA considers around 1,500 of them to be potentially hazardous. These space rocks are the remains left after the solar system was formed some 4.6 billion years ago. For example, in 2004, astronomers discovered a huge asteroid nearing Earth. The first observation showed that the chance of the space rock hitting our planet was less than 3%. The asteroid was named Apophis. It's more than 1,200 feet across and weighs about 20 million tons. It's supposed to streak across the sky on April 13, 2029. Apophis will pass at a distance of 19,000 miles away from Earth's surface. But even though the space rock might miss our planet in 2029, it doesn't mean it won't return 15 years later in 2036. If such an object hits our planet, the consequences will be unpredictable. They can vary from shattered glass and broken windows to most life forms getting wiped off the face of the Earth. And it'll probably affect the internet. Now that last thought is truly scary. But luckily, modern technologies are likely to help us avoid any catastrophic consequences. Experts have developed several ways to prevent a real-life disaster movie from happening. For one thing, we could use a spacecraft to knock this visitor from outer space off its course. Or it could somehow be blasted into pieces. Scientists could also slow the thing down with the help of concentrated sunlight. Or people could tug it away with a gravity tractor. That's a theoretical spacecraft that can influence objects in space without touching them. In sci-fi movies, a huge asteroid often sneaks up on Earth and turns out to be a nasty surprise to astronomers. It hurtles toward our planet at breakneck speed and gets discovered just weeks or even days before the collision. In reality, scientists are constantly watching all large objects in Earth's neighborhood. It means there would be plenty of time to do something before the inevitable happened. There are 3 kinds of missions scientists could prepare at short notice. Type 0, when a heavy spacecraft hurtles toward the intruder with one single goal: to knock it off its course. In this case, astronomers would have to rely on the already available information. The Type 1 mission would involve a scout. It would be launched first to get more close-up information about the space rock. Only after that, the main spacecraft would be launched. With more precise information, its journey would be way more productive. And if scientists chose the Type 2 mission, they would send a scout and a small spacecraft at the same time. The spacecraft would knock the asteroid a bit off its course. Then the scout would collect all the necessary information. Based on this data, the spacecraft would finish its job with a more fine-tuned second push. If none of these methods work, people could try going deep underground or even build a shelter on the ocean floor. But in this case, we'd need to find sources of energy that could help us survive for at least several decades. Plus, people would have to create a life support system that could somehow keep air and water fresh. It's staring at you, and you're staring at it. A giant eye that seems to be pulling you into an abyss. You're hovering over it in your space copter. But however scared you might be, you still need to do your job. So you send your copter down to the surface of the red planet. Right, that's where you are, on Mars. But first things first, you take a moment to remember everything you know about the 4th planet from the Sun. It's the last of the inner planets. Those are the planets that lie within the asteroid belt. They're also called terrestrial, since they're made up of rocks and metals. The atmosphere of Mars is much thinner than Earth's. It contains 95% carbon dioxide and a mere 1% of oxygen. In other words, don't even think about pulling off your helmet. Anyway, there's no time to waste. You land on the surface of the planet and find yourself in a brownish-red world. That's a good thing you're wearing a spacesuit. This place is freezing cold. The thermometer sewn into the sleeve of your suit shows minus 80 degrees Fahrenheit. Time to take your first step on the Martian surface. The planet looks quite colorful, and the hue of a particular area depends on the minerals that make up the soil. The ground under your feet is covered in fine dust. It looks like rust. The same orange dust is in the air. Good thing you have your own supply of oxygen and don't need to breathe Martian air. The layer of this dust covering the surface of Mars can be from 6 to 40 feet thick. You hope you'll avoid getting swallowed by some Martian quicksand. You start walking, feeling very light. Mars is just 15% of our planet's volume and a mere 11% of Earth's mass. It means that gravity here is much weaker. Its pull is 38% as strong as the pull of gravity on the surface of Earth. You jump up and down and then try to run several hundred feet. Ha! You haven't even broken a sweat. What makes it harder for you to explore the place on foot is that the planet's surface is rocky, covered with craters and volcanoes, old dry lake beds, and canyons. You see something huge towering on the horizon, but you try to suppress your curiosity. You'll have enough time to figure out what it is later. Suddenly, a massive cloud appears in the distance. It looks as if a huge herd of horses is approaching you. In reality, you better get back into your copter and fly away as fast as you can. That's one of Mars's infamous dust storms. They mostly occur during the summer in the southern hemisphere of the red planet. They can sometimes cover the entire planet, and you see the largest ones from Earth. You hop into your copter and set a course for the eye that scared you so much. Winding channels that look like veins run through the eyeball. But the closer you get, the less it looks like an actual eye. Soon you realize it's a crater. It's giant, almost 19 miles across. Around the crater, which looks as if it has a pupil, there are other even bigger craters. They likely formed billions of years ago. That's when Mars had to withstand multiple attacks of space rocks. But why is the eye crater darker than the surrounding landscape? Scientists think that once there was Martian water in the enormous pit. Remember those channels? They were likely carrying that water. And since the crater was filled with water, it stopped some substances and minerals from eroding away. Now, remember that towering something on the horizon? It's time to go and explore it. When you come close, you realize it's the largest shield volcano in the entire solar system, Olympus Mons. It's more than 370 miles in diameter, which is almost the same size as the state of Arizona. You tilt your head. Wow! The mountain is 16 miles high. It's also rimmed by 4-mile-high cliffs. To picture the sheer size of the volcano, let's make some comparisons. The largest volcano on Earth is Mauna Loa, towering around 2.5 miles above sea level and stretching 75 miles across. Sounds impressive. But the volume of Olympus Mons is around 100 times larger than that of Mauna Loa. The Martian giant could swallow the whole chain of Hawaiian Islands from Kauai to Hawaii. But why is this volcano so large? It might be the result of lower surface gravity and higher eruption rates. Or the reason might be the red planet's crust, which is very different from Earth's. It's static. You see, on our planet, the crust is made of 15 to 20 moving tectonic plates. As plates move over hotspots producing lava, new volcanoes form, and the already existing ones become extinct. That's why lava can get to the surface through many vents. But on Mars, the crust isn't broken into the same tectonic plates as on Earth, and the lava has nothing to do but pile in one very, very large volcano. So, how about getting closer to the enormous mountain? But once you step out of your copter on Martian soil, the ground under your feet starts shaking. Well, that's a Marsquake. But how can it happen if Mars doesn't have any actively shifting tectonic plates? Specialists from NASA are sure Marsquakes occur when energy inside the planet gets suddenly released. It leads to rock fractures and cracks in the planet's crust. Another powerful jolt, and one of such cracks opens right next to you. You fall to the ground, afraid to move, but soon everything calms down. You wait for a couple of minutes, just to be sure, and get up. Oh look! Here's a perfect opportunity to explore the insides of the red planet. The crack is large enough to send a special research robot. The planet's crust is thin and consists of volcanic basalt rock. The mantle that surrounds the core of the planet is made up of thick silicates, oxygen, and some minerals. You can probably compare it with soft, rocky toothpaste. Mars's mantle is also much thinner than Earth's. It's just 800 to 1100 miles thick. As for the planet's core, it's made mostly of iron, nickel, and sulfur and is between 900 and 1200 miles wide. This core doesn't move. That's why Mars doesn't have a planet-wide magnetic field. Unfortunately, your drone is now lost in the depths of the red planet. You leave it there and continue your exploration. Your next destination is Valles Marineris. It sounds more like an Italian red sauce, but it's actually an enormous canyon, or rather a canyon system, that runs along Mars's equator. It's as awe-inspiring as Olympus Mons, more than 2,600 miles long and over 4 miles deep. The thing is so huge, it could span the entire continental United States from the Pacific to the Atlantic Ocean. Now let's make another comparison. One of the most famous canyons on Earth is the Grand Canyon in Arizona, but it's 10 times shorter and around 4 times less deep than this canyon on Mars. Some scientists think that Valles Marineris is the edge of an enormous tectonic plate. It moves so slowly that almost nothing has happened in that region over millions of years, and the movement of this plate probably began 3.5 billion years ago. Anyway, the only thing left on your today's to-do list is to visit Mars's moons. They're among the tiniest in the solar system. Phobos is the largest of the two. It orbits a mere 3,700 miles above the surface of Mars. There's no other known moon that travels closer to its mother planet. It whips around the red planet 3 times a day, while the second moon, Deimos, needs 30 hours to complete one orbit. Phobos is getting closer and closer to Mars, about 6 feet each 100 years. Within the next 50 million years, it'll either crash into the planet or break apart and form a ring. Happy but tired, you return to your spaceship. Tomorrow, you'll continue exploring the magnificent red planet, and who knows what discoveries are awaiting you.
Imagine flying in a spacecraft in a cloud of asteroids at high speed. You dodge one more, and then hit the gas pedal to the floor and crash into an asteroid at full speed on purpose. This is exactly what NASA is going to do in the near future. The entire mission will begin at Vandenberg Air Force Base in California on November 24th. Let's follow it step by step. So, the Falcon 9 booster rocket is already on the launch pad. It's as tall as a 22-story building, or 11 giraffes, and it can get about 8 tons of cargo into orbit. So you could send a big elephant into space, and a supply of food for it. Countdown. 3, 2, 1, ignition! Smoke clouds everywhere, and the rocket begins to gain altitude. 9 engines are working at full power to accelerate the rocket. At its peak, it reaches speeds 10 times faster than the speed of sound. And then, the rocket engines shut down, and the rocket's first stage undocks to return to Earth. A couple of seconds later, the second stage receives the ignition command. It turns on its one engine and climbs even higher to orbit. The cargo capsule then opens and releases the DART spacecraft. DART stands for Double Asteroid Redirection Test. Once released, the spaceship deploys 2 large solar panels. It'll convert solar energy into electrical energy to power a revolutionary ion engine. Conventional engines create thrust by burning tons of fuel and ejecting it outward. The rocket itself is essentially pushing off the emitted gases. The ion engine will not burn fuel. It'll use a strong electric field to accelerate the ionized gas. Like conventional rockets, it'll eject this gas and create thrust by repelling it. And though the ion engine produces less thrust, it can accelerate the spacecraft to higher speeds. So regular rocket engines have an excellent performance on the road. They push the pedal to the metal, burning a bunch of fuel, while the ion engine slowly accelerates. But when a conventional rocket needs to make a refueling stop, the ion spacecraft will whiz past the regular one at insane speeds. So the DART spacecraft begins its year-long journey. By comparison, a flight to Mars would take about 7 months. Fast forward 1 year ahead, and we've arrived. This is the asteroid Didymos. The far point of its orbit is 2 astronomical units from our star. That's 2 Earth-Sun distances. At this point, the Sun begins to pull the asteroid back, and then it approaches the closest point to the star, 1 Earth-Sun distance. That is, its orbit lies very close to the orbit of our planet. Didymos made its closest approach to Earth at a distance of about 4.8 million miles. That's 20 times farther than the Moon's orbit. It takes 770 days to complete one such revolution around the Sun. So, Didymos is not considered a hazardous asteroid, but in the future, it'll approach the Earth even closer. And the consequences of a collision with it could be catastrophic, given its size. It's bigger than 2 Empire State Buildings, and it rotates at a rate of 1 revolution in 2 hours and 15 minutes. So it has a tremendous amount of energy. Plus, it has an asteroid companion. It's a small pebble 520 feet wide. It's like 12 school buses or 10 train cars. Its orbital period, that is, the time it takes the pebble to make a complete circle around the asteroid, is about 11.9 hours. NASA believes that asteroids up to 80 feet wide are likely to burn up completely in our atmosphere due to friction with the air, so they're not hazardous. Asteroids between 80 feet and half a mile in size will not burn completely and could cause severe damage. And asteroids over half a mile have the potential to wipe out large cities or even entire states. In that sense, we can consider Didymos potentially hazardous. So we're going to test one way of defending against asteroids on it: kinetic impact. That's why we sent DART here. So our spacecraft is going to hit an asteroid, only not its main body, but its little companion. DART is already moving toward it at about 4 miles per second. At that speed, a trip from New York to Washington, D.C. would take less than a minute, and a trip across the United States from coast to coast would take about 10 minutes. DART is getting close. 3 seconds to impact. 2, 1, BAM! The spacecraft crashes into the asteroid at full speed. What are your predictions? Asteroid explodes and is blown to pieces? Or asteroid flies off the main body into space like a billiard ball? Well, scientists predict that this collision will reduce the speed of this small asteroid by a fraction of a percent, but it'll still be enough to reduce its orbital period by a few minutes. Then our telescopes on Earth will be able to study the effects of the collision in more detail. And to learn even more, we'll send another spacecraft to Didymos on another mission. This is Hera. It'll be launched in 2024 and is scheduled to arrive at Didymos around 2027. This spacecraft will carry a bunch of research equipment to assess the collision damage done by DART. When it arrives, Hera will take many pictures of the small asteroid, including a fresh impact crater. Hera will also be carrying 2 CubeSats. These are miniature space probes, smaller than a shoebox. It'll launch these mini satellites, and they will make an even closer approach to the asteroid. They will study this space rock for 3 to 6 months. At the end of the mission, one of them will attempt to land on the asteroid's surface to learn even more about its composition and internal structure. It's also possible Hera will carry a mini impactor. This thing will have to make another impact on the asteroid. Then scientists will be able to evaluate the difference in impacts with a large spacecraft and a small one, and understand how we can defend against asteroids in the future. In theory, we don't need to send a giant rocket to a dangerous asteroid to destroy it. A single strike might be enough to shift the trajectory of the asteroid slightly. On a cosmic scale, changing the trajectory, even by a fraction, would dramatically change the asteroid's finish point. But kinetic impact is not the only way to deal with hazardous asteroids. Check out the gravity tractor. For this technique, we need to send a spacecraft toward the asteroid too. Only it won't crash into it. It'll have to go into its orbit. Any asteroid has a force of attraction, and it'll pull the spacecraft toward it. But the spacecraft's engines will keep it at the same altitude, so the asteroid itself will start attracting to the spacecraft. This method is reliable enough, but it takes a long time. And it'll only work if we detect a potentially hazardous asteroid many years before it arrives at Earth. We should have enough time to send a spacecraft to the asteroid and then carry out an asteroid tractor technique. The other option is a laser. When an asteroid is found, we need to aim a powerful laser beam at it. It'll heat up a certain point on the asteroid, causing the material there to evaporate. This is where physics comes into play. The material on the asteroid evaporates upwards. It makes the asteroid itself move downward. Just like our rocket engines work, the burning fuel is ejected one way and the spacecraft moves the other. We can also use solar power instead of lasers. To do that, we need to build a big space station, which would be equipped with a lot of magnifying glasses. Have you ever tried to burn letters on a wooden surface with a magnifying glass? Well, we'd be doing the same thing, but with an asteroid. The space station will have to focus lots of the sun's rays into one point on the asteroid. Again, the material evaporates because of the high temperature, and this causes the asteroid to change its trajectory slightly so that it flies past our planet. How about foil? That's right, we can avoid a collision with an asteroid by using ordinary foil. We would have to wrap the asteroid in the same reflective material. Then the asteroid won't absorb the sun's rays, but will instead reflect them. This creates a little pressure on the surface of the asteroid. It's as if the sun's rays are pushing the asteroid, and it'll be able to change its trajectory. And not the most obvious but reliable option is conventional rocket engines. We can put several powerful engines on the asteroid. This would create thrust and change the trajectory of the asteroid. And if there are enough engines, we can even take control of the asteroid. So when a bigger space rock appears on the horizon, we'll turn on our engines and point the asteroid straight at it. Such a collision can completely destroy even a very large asteroid, and it would make for one epic light show.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos